It's a really exciting time to be a JavaScript developer. Where companies used to need separate developers to work on their front end, back end, mobile apps, and databases, since all of those required experience with different types of programming, JavaScript can now be used to develop on each of these platforms, meaning that one JavaScript developer can now create something that used to take an entire team. And the rise of front end frameworks such as Angular and server runtimes such as Node.js mean that JavaScript has become something of a common language in the development world. In this course, I'll show you how to create and deploy a full-stack Angular-powered website from scratch. We'll start off by using Angular to create an interactive front end for our site, and then move on to writing a Node.js server tied in with a MySQL database that will support our front end. We'll then close out by seeing how you can host your full-stack site on Google Cloud and access it from anywhere. To get the most out of this course, there are a few things that would be helpful for you to know. First of all, it would be very helpful to have a basic knowledge of JavaScript, and ideally a basic knowledge of how front-end frameworks work as well. If you haven't already worked with these a little, I'd recommend you take a look at one of the JavaScript Basics courses in the library first, and then come back to this one, since we won't be covering any of the very basics in this course. It would also be helpful for you to have some experience with basic command line operations. All that we'll be using for this course is basic commands like makedir to make directories, cd to change directories, and ls to see the contents of a directory, as well as a few commands specific to Node.js that I'll show you later on. And keep in mind also that if you're on Windows, the commands might be a little different. If that's the case, take a look at the link that I have here to an article showing many of the basic Linux commands and their Windows equivalents. I also highly recommend that you follow along with me as I write code, but I've also included the start and finish state for all the code that I write in this course in the exercise files for your reference. Basically, this course is intended for developers who want to learn the ins and outs of building a full-stack website that incorporates front-end, back-end, databases, user authentication, and hosting. If that sounds like something you're interested in, then you're definitely in the right place. Let's install the tools necessary for this course. Node.js will be really important for running our code, and installing a few libraries we'll be using to make our programming easier. If you're not already familiar with Node.js, all you need to know for this course is that Node.js is an incredibly popular platform that allows you to run JavaScript code outside of the browser. This is really helpful since it means your JavaScript code doesn't have to be loaded and executed as part of a web page. In other words, you can write a single JavaScript file and run it from the command line. If you don't already have Node.js installed, you can download it from Node.js's website, nodejs.org. We're going to click on this button here and download it. And once it downloads, we're going to click on it to open it. And this should take you through the steps required for installation. Note that if you're using Windows or a Unix distribution, the steps might be a little different, but Node.js has instructions for all of these as well. And once you have Node.js installed, you'll want to make sure that you have the most recent version of NPM installed. We'll be using a few libraries in this course, and NPM is a package manager for Node.js that allows us to easily install them. To install the most recent version of NPM, just open your terminal and type npm install-g npm at latest, and you might need to run this with sudo as well. After that, type npm-v, and it should show the latest version. If the npm and node versions on your computer are higher than mine, don't worry about it, everything should still run correctly. But I do highly recommend having at least these version numbers here. And that's all there is to it. Node.js and npm are now installed on your computer. As with most courses on this platform, this course includes exercise files to help you follow along with the code I write. For the most part, it's probably more or less what you're used to. There are just two things that are important for you to know about the exercise files for this course. The first is that there are two separate projects for this course, a front-end project and a back-end project. For both of these, before you're able to run any of the code, you'll need to run the command npm install inside the project directory. And what this will do is install all the associated npm packages that each project needs. The second thing to note is that once we get into the section on user authentication, the exercise files will require that you also follow along with the corresponding setup on Google Cloud and Firebase. In other words, they won't work if you just try and run them as is. Well, that's about all you need to know for that. Let's take a look at the project we'll be building. So as I mentioned, in this course we'll be using a number of different technologies to build and host a full-stack web application. And the application that we'll be building will be a listing site, something similar to sites like Craigslist, where users will be able to list items for sale and view items that other users want to sell. And this site will also include things like user authentication. That is, it'll allow users to log in and out using their Google account and use that to keep track of whose listings are whose. So the front end of this site will be built using Angular, which again is a very popular and easy to use front end framework. And this front end site will be served by a back end written for a Node.js environment. And it'll use a very popular server framework called Happi to make the task of creating an API easier. And the backend will also store all its data in a MySQL database. And after we've built all that, we'll be adding user authentication to our site using something called Firebase Auth, and then we'll host our entire full-stack application on Google Cloud. Well, that's about it. Let's get started. So we're going to be building the front end of our buy and sell site using Angular. Now, you might be wondering why we choose to use Angular instead of just creating our site using basic HTML, CSS, and JavaScript, or instead of using some other low-code solution such as WordPress or Wix. Well, compared to hand-coding a site, Angular has a lot of advantages. The main advantage is that it makes the task of creating a performant website much simpler and faster without taking away any of the fine-grained control from the programmer. It allows us to create these modular, reusable components that can then be arranged into a fully functional website instead of hand-coding each individual page in our site. Imagine, for example, that we have a blog site with 100 articles, each with pretty much the same structure. Now, what if we wanted to add a sign-up form to the top of all of our pages? Well, if our site was just a collection of HTML documents, we'd have to make the same exact change to 100 separate files, which, isn't a pleasant task by any stretch of the imagination. With Angular, on the other hand, all of our pages would be based on a single reusable page component, so we'd only have to make this change once to see it across all the pages. So the next question is why you'd use Angular over a platform like WordPress or Wix or Squarespace, which allow you to create a website without writing much, or in any cases, any code. Well, first of all, since this course is aimed primarily at developers, if you want to create a blog and you're not already a fairly strong developer, I actually would recommend that you use one of these platforms instead of Angular, since it'll probably end up being much more difficult for you in the long run if you try to create a code-based site if you still struggle with basic coding. So another question is why you'd choose Angular over some of the other web frameworks like React or Vue. And the answer to this question is that it kind of depends on your personal situation and needs. Angular is definitely more opinionated than the other major frameworks. And what this means is that, as we'll see while we're building our site, for most use cases, Angular provides some sort of guidance on what exactly the preferred way to do things is. And this is something you wouldn't find in React, for example, where there are often many different ways to accomplish pretty much the same thing. And this means that Angular can be especially helpful if you're fairly new to front-end development and don't yet have the instincts that only come from years of creating web applications. And ultimately, if you're still wondering whether to use Angular or React or Vue, really the best way to see the differences between all these frameworks is to just try them out for yourself. Try building the same apps using all three and see what you like and don't like about each one. All that being said, Angular is a fantastic tool for programmers who want to create basically any type of web application. And with technologies out there like NativeScript and Ionic, it's become a tool for creating mobile apps as well. Angular developers are currently highly sought after by many companies who are looking to modernize their web apps or stay ahead of the curve. So with that knowledge, let's move on and see how we can quickly set up an Angular-powered front end for our web application. Now that we know a little bit more about Angular and some of its benefits, let's get started creating an Angular front end for our own project. Now, there are a few steps to doing this, but overall, it's a fairly straightforward process. The first thing we're going to do is open up a terminal, and I'm using VS Code and VS Code's built-in terminal here. And inside that terminal, we're going to run the command npm install -g @angular/CLI and hit enter. And you may need to put the sudo keyword before this command if you get something about permissions like I am here. And now we have what's called the Angular CLI installed globally on our computer. And what this means is that we can use commands such as ng to perform Angular-related tasks, such as creating new projects. So what we're going to do is change directories into the directory that we want to create our actual project into. And once we're there, we're going to run the command ng new, and then the name of the project that we want to create. In our case, since we're creating a buy and sell site, we'll say ng new, buy and sell, and hit enter. And it's going to come up with a question asking us if we want to add Angular routing, and we want to answer yes to that. And then it'll ask us what style sheet format we want to use for our project. We're just going to select CSS here. And once that completes, we can change directories into the new project that we created. So we can say cd buy and sell. And then in order to actually run our project, what we can do is type ng serve, and we can optionally add this -o tag here, which will open up a new tab with our app in it. And here we see our app, which contains a lot of boilerplate that the Angular generator generates for us, open in a browser. Obviously, we're going to make a lot of changes to this here. We're pretty much going to delete this whole app and start fresh, but the point is that we now have a running Angular app. So now that we have our Angular project created and running, let's actually open it in our IDE. And once we've done that, this is a great chance to take a look at the structure of our Angular project. So in our file tree here, you'll see that there's a lot of files that Angular generated for us. Most of what we're going to be concerned with is inside the source directory. Outside of there, you have mostly just a bunch of configuration files that you can change at will. But then if we go inside our source directory, let's take a look at some of the files and directories inside of here. So first of all, we have this app directory, which contains all of our component code. This is where we'll be spending most of our time in this course. And then we have this assets directory, which contains any special assets our project needs, such as images. And then we have this environments directory, which contains files for specifying different environment variables, which can be very useful for having a dev and a production environment. And we also have this index.html file. This is where the Angular app gets rendered into, and specifically it gets rendered into this app root element here. Let's see, we also have this main.ts file, which is the entry point for our Angular application, as well as this polyfills file, which contains any special packages that we need to import for browser compatibility. I usually use this to import packages that'll make certain things work on, Internet Explorer, for example. And we also have this styles.css file, which is where we can add any global styling that we want to our project. And lastly, we have this test.ts file, which launches testing for our application. We won't be using this at all in this course, but if you want to do stuff like test-driven development, this is where you do it from. So anyway, that's the basic high-level structure. Let's take a closer look at this app directory inside our source directory here. Now, the first thing to notice inside this directory are these app.component.ts, app.component.html, and app.component.css files. Now, as you'll see, these are the files that control the various pieces of our application component, which is basically the component in our Angular application that contains the rest of the components we'll create. And as you'll see, all components in Angular consist of these three files: the CSS file, the HTML file, and the TypeScript file, as well as this spec file, which is used for testing. So the HTML file, for example, is where we define what the actual DOM structure of our component looks like when it gets rendered into the user's browser. Right now, it just contains a bunch of boilerplate code, which is what we saw when we ran our project. And then we have our app.component.ts file, which is where we define the data that gets displayed inside our component, as well as the logic that sort of goes on behind the scenes. And of course, the CSS file here is where we define component-specific styling. So anyway, those are the basic files for our app component, which, as I mentioned, is the root-level component for our application. Some of the other files that we have in here are the app routing module file, which contains the routing logic for our app, and we'll see exactly how to use this file in a few minutes. And we also have the app.module.ts file. When we want to import a module into our Angular application, we usually have to add them here. And we'll see how this works when we do things like add network requests to our front end when we link it up to the server we'll be creating. Note too that any other components we create in our application need to be added here as well, although this will usually happen automatically as long as we use Angular's scripts to create our new components. And we'll see more on that in a minute. So now that we've seen the basic directory structure of our Angular project, let's move on to creating the first component for our application. Components are the basic units of organization in Angular projects. They're these sort of modular pieces of the interface that we can define and display inside other components. And as I mentioned already, the app component that we looked at is the component in Angular applications that contains the rest of the components we create. The first component we're going to create for our buy and sell site is going to be the listings page, which will display all the currently available listings that a user can buy. Now, when creating a new component in our Angular projects, instead of creating all the files and setting up all the boilerplate code ourselves, Angular provides a script that we can run to generate all of that for us. So in order to generate our listings page component, for example, we can just open up a terminal and run the command ng generate component, and then the name of the component we want to create. In our case, it'll be listings-page, and hit enter. And that'll run and generate all the files and code we'll need for that component. If we look inside our app directory now, we see that we now have this listings page folder inside our app directory that contains the same files we saw with our app component, the CSS, HTML, spec, and TS files. And if we take a look at our HTML file, we see that the HTML that will be displayed for this component just says listing page works. And we're going to change this to something more useful shortly, but for now, let's see how to actually display this component in our application. If we look inside our component's component.ts file here, we see that we have this funny looking component decorator here, which basically just contains metadata about our Angular components. Don't let the syntax throw you off here. And inside this decorator, we see that we have this selector property, which is app listings page, and this is the tag that we can use to insert this component into another component's HTML. So for now, what we're going to do is open up our app components HTML file. And the first thing we're going to do here is remove all the sample code they gave us. And we want to delete everything in this file except for this router outlet here. And we'll talk about what this is exactly and why we want to keep it in a bit. And then what we're going to do to display our listings page component is we're going to simply say app-listings-page and close that bracket. And this will insert the listings page component we just created into our app component. And if we run our project again by saying ng-serve-o, we see that it's now displaying the listings page here. Now, this isn't super exciting yet, but that's the basics of creating a new component and displaying it inside another component in Angular. So right now we've got our listings page component displaying inside our application. And we'll get into actually implementing our listings page soon, but first let's take a look at how routing works in Angular. As in virtually every web application, we'll want the different components and pages of the application we're going to create to be displayed as the user navigates to different routes in their browser. For example, we'll want our listings page to be displayed on our /listings route, and we'll want our My Listings page to be displayed on our My-listings route, and so on and so forth. So implementing this kind of functionality in Angular is actually really simple to do. All we have to do is open up our app-routing.module.ts file here. And you see this const routes array here? Well, what we need to do is add an object to this array for every route that our application needs. So in the case of our listings component, here's what that's going to look like. We're going to create a new object here, and we're going to say path, and then the URL that we want our component to be displayed at. In our case, it's going to be listings. And then we have to specify the component that we want to be displayed at that route. In our case, that's going to be our listings page component, which we have to actually import from its file. So we'll say import listings page component from ./listings page/listings page.component. And one last thing that we're going to add to this object is path match, and then the string full. And we need to add this path match thing because of another page we'll be adding that will allow our users to see the details of a specific listing. You'll see why in a second. And now let's save this file and go back to our app components HTML file. And we're just going to delete this app listings page tag that we put in there before and save it. And if we take a look at our application now, what we're going to have to do is go to /listings here. And then and only then will we see our listings page components HTML displayed. So anyway, that brings us back to our app's HTML file. You see this router outlet tag here? What that is the location on the page where the component matching the current route will be rendered. And right now that's not very exciting since it's the only thing in the HTML, but just to illustrate, let's add a heading above our router outlet that says something like buy and sell app. And now what we see is that our heading gets displayed no matter what route we're on, while our router outlet gets replaced with whatever route-specific content we've defined in our app routing file. And as you might have guessed, this kind of thing is very useful when we want to do things like add a navbar to our application. And that's actually something we're going to be doing shortly. But first, while we're on the topic of routing and displaying different components at different routes, why don't we take this opportunity to create the rest of the pages we'll be needing for our application and add routes to them. So here's what that'll look like. Let's open up a terminal, and we'll temporarily kill our app. And we're going to use that same ng-generate component command to generate all the rest of the pages for our application. So the first page we're going to need is a page for displaying more details about a given listing. So in our terminal, we're going to say ng-generate component, and we'll call this new page listing detail page, and hit enter. And we'll also want a page for contacting the owner of a given listing, which we'll call the contact page. So we'll say ng-generate component contact-page, and hit enter. And then we're going to add a page that will display a list of the user's own listings. So we'll say ng-generate component, and we'll call this the My Listingspage. And we're also going to add pages for creating new listings. ng-generate component, new listing page. And also a page for editing existing listings. So we'll say ng-generate component, edit, listing page. And that should be all the page components we'll need for now. So the next thing we're going to do is inside our app routing module file, we're going to add a route for each of the pages we just created. So we'll start off with our listing detail page. So we'll say path, listings, /:ID, and right off the bat, there's something different about this route. We have this :ID thing here, which is what's called a URL parameter. We'll be using this to display the data of a particular listing on this page. For example, we might have /listings/123, which would display the data for the listing with the ID 123 on the page. We'll see exactly how this works a little later. And note also that this route is the reason that we had to use this path match full thing on the route above it. If we didn't use that, our listings page route would automatically match and take precedence over this route, since technically the route /listings matches when the browser's URL is /listings/123 or /listings/anything else. And that's just something to keep in mind. So anyway, let's continue with this route. We're going to want to display the listings detail page component here. And we'll import all of these components at the very end, by the way. And then we're going to define another route for our contact page. So we'll say path, contact, and we're going to use this :ID thing again. And the component for that will be our contact page component. And actually, now that I'm thinking about it, this is listing detail, not listings detail page component. And after that, we're going to have our edit listing page component, which is going to be edit listing and the URL parameter thing again. And for that component, we're going to say edit listing page component. And then we'll have our My Listings page, which will be My Listings, and the component will be My Listings page component. And last but not least, we're going to have our new listing route, which is going to look like this: path new listing, component, new listing page component. And of course, we're going to have to import all of these components, which is going to be a little bit of a pain, but nothing we can't handle. So we're going to say import listing detail page component from /listing detail page /listing detail page.component. Import contact page component from contact page /contact page.component. Import edit listing page component from edit listing page /edit listing page.component. Import my listingspage component from my listingspage /my listingspage.component. And last but not least, import new listing page component from new listing page /new listing page.component. And now that we have all that, the last thing we're going to do here is set up a redirect so that when the user visits the home route, that is just the / route, they're automatically redirected to the listings route here. And here's what that's going to look like. We're going to have one last route whose path is just an empty string. And we're going to say redirect to /listings. And the path match here is going to be full to prevent it from interfering with our other routes. And now, if we have our application running, which I have to restart mine by saying ngserve-o. And now what we can do is go to any of the routes that we define, such as my-listings, and see the corresponding page component displayed at that route. So if we go to /listings/123, for example, we see our listings detail page. If we go to new listing, we see our new listing page, and so on and so forth. And also, if we just go to our home route, we see that it automatically redirects us to the /listings route. So one last thing here is let's just delete this heading tag and save it. And that should be all we need for now. Now that we've got our pages and their corresponding routes set up, we're going to start implementing each page of our application. But before we do that, there are a few things we have to do first. The first thing is that we have to add some fake data to our application. Later on in the course, when we create our backend, our front-end application will just load all of its data from there. But for now, while we're just building out our front end, we're going to define some fake data that we can use instead. So inside our app directory, let's create a new file and call it fake-data.js. And then, in order to populate this file with fake data, what we're going to do is copy and paste that data from this project's exercise files. So just go to the end state for this video and copy and paste the data from there. And then we'll paste that inside here. It'll look something like this here. And once we've done that, the second thing we need to do here is, since the fake data we just copied and pasted contained a new TypeScript type, we need to actually define that type so that we can use it throughout the rest of our front end. So inside our app directory, let's create another new file called types.ts. And then inside this file, we're going to define a listing type, which will look something like this. We'll say export interface, listing, ID, string, name, string, description, string, and price will be a number. And let's save that file. And then we'll go back to our fake data file and import that type we just defined. So we'll say import listing from types. And it looks like I accidentally named this file .js. That should have been .ts, so we'll rename that here. And now that we've got all our fake data set up, there's one last thing we're going to do here. In order to make our application look a little more exciting than just basic unstyled elements, what we're going to do is copy and paste some CSS that I've written for this app. Again, if you go into the project's exercise files and take a look at styles.css in the app directory, you should copy all of those styles into your own project's styles.css file. And that'll look something like this, and then we're going to save that file. And that's all we really need to do here. Now, note that in a full-scale application, having all of the styles for our entire application in one spot like this is probably not the approach we'd want to take. What we'd want to do instead is split these styles out and put them in the CSS files of their corresponding components. But in order to make it easier for you to just copy and paste, I've put them all in one file like this. And keep in mind too that as we develop the rest of our front end, we're going to be adding some classes and IDs to our HTML elements for the sole purpose of making them match up with these styles here. Now that we've got all of that setup out of the way, let's start implementing our listings page component. Remember that this page is going to display a list showing all the available listings on our site. Now, in reality, our site might have thousands of listings, and in this case, we definitely want to paginate our results. But in this course, we're going to ignore that and just display all our listings on a single page. So here's what implementing our listings page is going to look like. It's going to involve making changes to two files here, our listings page TypeScript file and our listings page HTML file. So let's open both of those files up. Now there's really only one main thing we'll want to do inside the TypeScript file for now, and that's define a listings array to contain the listings that we want to display. So up at the top of our component, let's define this variable. We're going to say listings, and it's going to be an array of our listing type, and the initial value is going to be an empty array. And then, of course, we have to actually import this listing type up at the top of our file. So we'll say import listing from types. And while we're at it, let's also import our fake listing data that we copied and pasted from GitHub. That's going to look like this. We'll say import fake listings from ... fake data. And then inside this ng-on-init method of our component, we're going to set our listings member variable equal to these fake listings that we imported. So we'll say this.listings equals fake listings. So one question you might have right here is, why aren't we just setting our listings equal to our fake listings right where we define the member variable, right? Why don't we just say listings equals fake listings up here? Well, the reason we're doing it this way is because right now we're just using fake data, but later on we'll be loading this data from the server, and the proper place to do this in Angular is inside the ng-on-init method, not in the constructor or up here at the top of our component. So now that we have this data defined for our component, let's save our file, and then head over to the HTML file and define our component's structure. So here's what that's going to look like. We're going to delete this listings page works thing here, and we're going to wrap our entire component in a div, and then we're going to say div class equals content box. Again, this is just for styling so that it matches up with the styles we copied and pasted. And then we're going to do something that I'll explain in just a moment. We're going to say star ng4 equals let listing of listings. So this ng4 is something new here. It's what's called a structural directive. Structural directives in Angular allow us to change the structure of the HTML on our page depending on the underlying data in our TypeScript file. So in this case, what we want to do is display a separate one of these divs for each and every listing in our listings array, which is what this statement here does. And by the way, the little asterisk here is how we denote structural directives in Angular. So the next thing we're going to do is display the name and price of each of our listings inside a link. And here's what that's going to look like. We're going to say a router link equals, and I'm going to explain all this syntax in just a second here. Just follow along for now. /listings / double curly braces listing.id. And inside those tags, we're going to say h3 double curly braces again, listing.name, dash, and then a $sign, and then double curly braces, listing.price. So there's a few new things here, right? The first is this double curly brace thing. This is how we insert the values of variables from our TypeScript file into our HTML page. In this case, we're inserting the values of the listing's ID, name, and price into various parts of our HTML. And the second thing to notice here is that inside our anchor tag, we're not using the href attribute like we normally would in HTML. Instead, we're using this router link attribute. What this allows Angular to do in our app is change the URL in our browser and the content displayed in our app without reloading the page, which is what would happen if we used the href attribute. And that's pretty much all we need for this component. If we make sure our app is running, which we can do by running ng-serve-o, and then head over to our app in the browser, we see that it's now displaying our fake listing items perfectly, and that we can click on the names of each of these items and it will link us to our listing detail page. So now that we've got our listings page working and linking to the corresponding detail page for each listing, it's time to actually implement the listing detail page. So let's open up our listing detail page TypeScript and HTML files, and before we begin here, there's something to know about this page. Remember that earlier when we were creating the routes for our application, there were several routes that we created with this ID URL parameter thing. Now, you may have noticed that when we navigate from our listings page to our listing detail page, the URL that we're navigating to contains the ID of the individual listing that we clicked on. So what we're going to have to do on this page is somehow get access to the value of this part of the URL and use that to display the corresponding listing from our fake listings array on our page. So here's how we do that in Angular. Let's open up our TypeScript file here. And then we're going to start off by importing something up at the top. And this is going to be something called activated route. So we'll say import activated route from @Angular/router. And once we've done that, we're going to do something here that I'll explain in just a second. Inside the parentheses of our component's constructor method, we're going to say private route activated route. Now, the syntax of adding things like this is a very common pattern in Angular. In Angular, there are a pretty large number of different so-called providers that we can add to our components in order to enable them to do certain things. In this case, this activated route provider will allow our listing detail page to access the value of the URL parameter in the current path. And here's how that's done. Inside our ng-on-init method, we're going to say const ID, and then to get the ID parameter from the URL, we're going to say this.route.snapshot.param_map. It's a pretty long series of dots here. .get, and then a string that says ID. So that'll get us the URL parameter with the name ID. So now that we have that ID, what we're going to do is use it to display the correct listing from our fake listings data. So first, let's import that fake data. We're going to say import fake listings from ... fake data. And let's import our listing type as well. Import listing from ... types. And next, we're going to add a member variable to our component called listing that'll contain the selected listing that should be displayed. So we'll say listing, and we'll reference this listing in our HTML in a second. And then what we're going to do is down here inside the ng-on-init method, where we got the ID, we're going to assign the matching fake listing to this variable by saying this.listing equals fake listings.find, and then we're going to find the listing whose ID is equal to the ID parameter that we got from the URL. And that's about it for our component's TypeScript file. So next, what we're going to do is head over to our component's HTML file and build out the structure for our component. So here's what that's going to look like. We're going to say div class equals content box for the styling. And then we're going to have a link that goes back to our listings page. This will be the sort of back button here. So we're going to say router link equals /listings. And inside there, this is pretty much just to make it look good. We're going to have a button that says back. And then underneath this back button, we're going to display some information about our listing. So we're going to have an H2 heading that contains the name of the listing. So we'll say listing.name inside curly braces. And then we'll display the listing's description. So listing.description. And then we'll display the price for our listing. So we'll have a $sign, and then we'll say listing.price. And then at the very bottom of this page, we're going to have another link that'll take the user to the contact seller page so that they can send them a message saying they're interested about this product. So we're going to say a router link. Oops, and I'm noticing that I said route link here instead of router link. That should have an R. Router link equals /contact / and then listing.id in curly braces. And that's going to have a button inside it as well. So we're going to say button contact seller. And that should be it for our listing detail page. If we go back to our browser where our app is running, we should see that we have all those things. We have the back button that takes us back to the listings page. We have the basic information about the given listing. And we have the contact seller button that takes us to the contact page. So we have the listing detail page set up to link to the corresponding contact seller page. So what we need to do now is something very similar to what we did with the URL parameters in our listing detail page. We're going to pull the listing ID out of the URL for our contact page and use that to allow a user to send a message to the seller saying they're interested in buying the item. Well, in this course, we're not actually going to cover sending emails programmatically. If you want to see how that's done, I'd recommend taking a look at my Firebase course where I show how to do this from the backend using a package called NodeMailer. For now, what we're going to do is just display an alert saying that the user's message was sent. So let's head over to our IDE, and let's open up our contact page's TypeScript and HTML files. And we're going to start off in our TypeScript file by importing a few things. We're going to say import activated route, which we'll be needing just like we needed in our listing detail page. And we're also going to need something called router, which we'll be using to navigate programmatically. You'll see how this is done in just a second here. And we're going to say from Angular/router. And then we're going to import our listing type from our types file. And we're going to import our fake listings from our fake data file. And the next thing we're going to do is add a few member variables to our component. The first one is going to be called email, and it's going to be a string with the starting value of just an empty string. What this is going to do here is store the current value of the input for the user's email address. We'll see how to link that up to an actual input shortly when we work on our HTML file. And we're going to have several other text inputs on our page. We're going to have one for the message that the user wants to send to the seller, and that'll be a string as well. And then we're going to have another member variable that'll be the corresponding listing from the ID URL parameter. So the next thing we're going to do is we're going to inject this activated route and router provider things here into our component by adding them to our constructor, just like we saw with our listing detail page. So we'll say private route, activated route, and private router. And the next thing we're going to do is, just like in our listing detail page, we're going to pull the listing ID out of the URL parameter and use it to select the correct listing from our fake listings array. And again, that'll look like this. We're going to say const ID equals this.route.snapshot.param_map.get ID. And then we're going to say this.listing equals fake listings.find. And we're going to find the listing whose ID is equal to the ID that we got from the URL parameter. And then what we're going to do is we're going to use this listing that we pulled out to set a default message for the message input. So here's what that's going to look like. We're going to say this.message equals And then in backticks here, we're going to say, hi, I'm interested in your, and then we'll just have the name of the listing here. So we'll say this.listing.name, and we'll convert that to lowercase here. And we'll put an exclamation mark at the end. So again, that'll be the starting value of the message input for the user. And then what we're going to do is underneath this ng-on-init method, we're going to add a new method to our component that'll get called when the user clicks the send button on our page. We haven't implemented that yet, but we'll get to that in just a second. And what that's going to look like is something like this. We're just going to say send message. And that won't return anything, so we'll say void. And what we're going to do is just display an alert that says something like your message has been sent. And then we're going to say this.router. That's our router provider that we had up here. We're going to say this.router.navigate by URL. And we're going to have it navigate to our listings route. So it'll just display an alert here, and then it'll navigate back to our listings page. So that's all for our component's TypeScript file. Let's move on to the HTML file. Let's make sure we save this first, and then move on to the HTML file. And there are going to be a few new concepts here, so watch closely. The first thing we're going to do is just have a div with the class of content box, just like with our other ones. And then we're going to have an H3 heading that says something like send the owner a message. And we're going to have a div here that'll contain our form. So we're going to have a label. And we're going to have a label that says your email address. And then an input whose name is going to be email. And then we're going to do something a little different that I'll explain in just a second. We're going to do square brackets, then parentheses, and then inside that ng model. And then we're going to say that that's equal to email. Okay, so this thing here is our first point of interest. What this square bracket parentheses ng model thing does is creates a two-way binding between the value of our text input and the email member variable of our component. In other words, whenever the value of our input is changed by the user, the value of our email variable will change as well, and vice versa. Now, this won't actually work at the moment. In order for this to work, we have to actually open up our app module file. So app.module.ts. And remember earlier in the course, I said that this file is where we define some important imports and exports of our Angular project. Basically, there are quite a few important things that we can import into this file that extend the basic functionality of some aspects of Angular. In our case, in order to get the two-way binding thing to work for our project, what we have to do is import something called the forms module from Angular, which will look like this. We're going to say import forms module from @Angular/forms. And then we have to add this forms module thing to our imports array here. So we're just going to say forms module. And now that we've done that, let's head back to our HTML file and finish it up. So we're going to add another div here, and then another label. And we're going to say your message. And we'll have a text area here, whose name is going to be equal to message. And we'll just say it has 5 rows and 20 columns. And then we're going to use the ng model thing for this as well. So we're going to say square brackets, parentheses, ng model equals, and this is going to be equal to the message member variable from our component. And then at the bottom of our page, outside this last div here, we're going to say button, and then in parentheses, we're going to say click. I'll explain this in a second. And we're going to say send message with parentheses after it. And the button will say send on it. So the last thing to notice here is this click thing in parentheses. As you may have guessed, this is how we hook into events such as clicks in Angular. In this case, what we're saying is that we want the send button to call our component's sendMessage method, remember this method that we defined right here, when it's clicked. And it's as simple as that, really. So now we should be able to go back to our contact page and see that everything is working as it should be. We can input an email address of ours, and we can add something else to the message, and when we click send, it's just going to display an alert that says your message has been sent, and when we click OK, it's going to navigate us back to our listings page. Okay, so far we've made it through the whole listings page flow. We have the listings page itself, along with the listing detail page and the contact seller page. So now what we're going to do is we're going to move over to the other side of things. We're going to create the pages that will allow users to view, create, and edit their own listings on the site. The first of these pages we're going to implement is the My Listings page. So let's go back to our IDE and open those files. We're going to open the TypeScript file and the HTML file. So this page will just display a list of the listings that a user has created. And as with the rest of our data on the front end so far, later on in the course we'll be loading a user's listings from the back end, but for now we're going to import them from our fake data file. So inside our TypeScript file, let's say import fake my listings from fake data, and then we'll import the listing type as well. Import listing from /types. And for now, the implementation of this component is going to be pretty boring. Mostly this page will just link to our other pages for creating or editing listings. So here's what our component will look like. We're going to start off by giving it a listings member variable, which is going to be an array of type listing. And then inside ng on init, we're going to say this.listings equals fake my listings. And then we're just going to create a method for deleting our listings, which will look like this. We're going to say on delete clicked listing ID will be a string, and it's going to return void. And for now, this method won't actually delete anything yet. We'll get to that when we add a backend to our application. For now, we're just going to say alert in backticks, deleting your listing with ID, listing ID. And that's it for our component's TypeScript for now. So let's head over to the HTML file, and it's going to look something like this. We're going to say div class equals content box. And we're going to use another structural directive here to map over all of our components listings. So we'll say star ng4 equals let listing of listings. And then we're just going to display some very basic information about our listing. So we'll have an h3 heading with the listing's name. So listing.name inside curly braces. Then we'll have the listing's description, so listing.description. And then we'll have a $sign for listing.price. And then we're going to have two buttons for each listing, one that will allow us to edit the listing and one that will allow us to delete the listing. So here's what that's going to look like. We're going to say div class equals buttons container. This is for styling purposes here. And then an anchor tag with a router link equal to edit listing. This will link to our edit listing page with the correct listing ID. And inside there, we're going to have a button that says edit. And then we're going to have a button underneath that that actually has something linked up to its click method here. So we're going to say click equals on delete clicked listing.id. And this button will have the text delete on it. And that should be it for our My Listings page implementation. So let's head over to our application, and we see that it's working just like we want it to. If we click on edit, it links to our edit listing page. And if we click on delete, it shows us an alert saying deleting your listing with ID 789. And we click OK. And of course, once we actually hook the front end up to our back end, it'll actually delete those listings. But for now, it just shows that alert. Okay, next let's implement the new listing page. So first of all, we need to actually add a button for getting to the new listing page. And for that, we're going to go back to our My Listingspage component.html file. At the bottom, underneath this div that we're using this structural directive on, we're just going to add an anchor tag with the router link equal to /new listing. And inside that, we're just going to put a button that says create new listing. And now we have this button that we should be able to click, and it takes us to our new listing page. So let's implement this page. We'll start off by opening up our new listing page, HTML and TypeScript files. And the implementation of this component for now will be very similar to what we saw with our contact page component. It's going to contain a form with text inputs whose values will be linked to member variables inside this TypeScript file. So what we're going to do first is define those member variables. Each of these is going to be linked to a given text input on our page. So we're going to say name, and this is going to be a string. It's going to start off as an empty string, and then we're going to say description, and the same thing for that. And price is going to be a string right now as well. And then up at the top of our component, we're going to import router from Angular/router. We're going to be using this to navigate programmatically, just like we did in the contact seller page. And inside this constructor, we're going to say private router. And then the last thing we're going to do inside this TypeScript file is define a new method for our component called onSubmit. And it's going to be void. And inside this, what we're going to do for now is we're just going to display an alert that says creating a new listing. And then underneath that, we're going to use this router provider here to navigate back to our My Listings page. So we'll say this.router.navigate by URL /My Listings. So there's nothing too strange in this TypeScript file. Let's move on to our HTML file now. So we're going to delete that boilerplate code there. And we're going to say div class equals content box. And an H2 heading that says create new listing. And then we're going to have a form here. And then in parentheses, we're going to say ng-submit equals onSubmit. And what this is doing is saying that when the user clicks the submit button on our form, it'll call the onSubmit method of our component. This is very similar to the click method that we've seen on buttons. So anyway, the implementation of this form is going to look like this. We're going to have a div and a label inside of it that says for equals name, and that'll say name. And underneath that, we're going to say input ID equals name, name equals name, and type equals text. And then we're going to use the ng model thing again, so square brackets, parentheses, ng model. And we're going to link the value of this text input to the name member variable inside our TypeScript file. And that's it for that input. The other inputs are going to look pretty much the same as this. We're going to have a div that has a label for description. We're going to say item description here. And then we're going to say ID description, name description, type equals text, and ng model is going to be description this time. And last but not least, we're going to have a text input for our price. So we'll say label for price, price, ID price, name price, and ng model. We're going to link that to the price member variable. And then underneath all of those, we're going to have the submit button for our form. It says button type equals submit. And we'll make the text of that say create listing. So that should be all we need for our new listing page. And now if we head over to our new listing page again, we see that we have this form that we can use. So we can just fill out some basic data, click on create, and actually that's not going to work because I typed this in wrong. It should be ng submit. That's one of my very common typos there. Save that. And now, oops, we need to fill out that info again. And if we click create listing now, we get an alert that says creating new listing. And if we click OK, then it takes us back to our My Listings page. The next thing we're going to do is move on to implementing the edit listing page. Now, the edit listing page component will look very similar to the new listing page. In fact, it'll look so similar to this page that it would really be a shame to waste so much code implementing basically the same exact component. So what we're going to do instead is create an entirely separate component for the form that both of these pages will have in common, and then simply reuse this form on both pages instead of duplicating the logic in HTML. So what we're going to do here first is open up a new terminal, and we're going to generate a new component called listing data form by saying ng generate component listing data form, and hit enter. And now that we've created that component, the first thing we're going to do is see how to actually display it on our edit listing page. So let's open up our edit listing page components HTML. And this is pretty simple, really. Let's just add a few things here. We're going to say div class equals content box. We'll have an h2 heading that says edit listing. And then to insert our listing data form into this component, we're going to say app listing data form, just like that. And now if we take a look at our edit listing page, we should see this little listing data form works message here. So now let's actually implement our listing data form component. Let's open up both the HTML and TypeScript files for it. And really what we can do here is open up some of the files from our new listing page component, the TypeScript and the HTML files, and we can copy a lot of that code into our listing data form component. So for example, we're going to copy this router thing here, and we're going to put that inside our listing data form component's TypeScript file. And then we're going to copy basically the whole body of this component here, and paste that into our listing data form component's body. Just like that. And then we're going to do the same thing with the HTML. So we're going to go into our new listing page component's HTML file, and we're going to copy this whole form component. We're not going to copy the outer div or h2 tags. And then inside our listing data form component's HTML file, we're going to paste all of that HTML and save it. And now if we look back at our edit listing page, we see that it has the form and the button that we want it to have. However, before we get too smug here, there are a few things that aren't quite right about this setup yet. For one, we need to display different text on the form button depending on where we're actually displaying it from. Right now, it just has this create listing thing hard-coded into it. And the second thing that we need to do is allow whatever component is displaying the listing data form component to handle the onSubmit action itself. Because right now the listing data form is set up to just create new listings, right? If we click on this button, it'll display creating a new listing even though we're on the edit listing page. So how do we do things like this in Angular? Well, actually, this brings us to a very important concept called inputs and outputs in Angular. Notice how with the rest of the HTML elements on our page, we're able to use attributes to customize the elements in some way, whether that's by assigning a class to an element, or applying inline styling, or a lot of other things. And also notice how we've been able to tap into things like button click events or submit events with this parentheses syntax here. And as a matter of fact, it's possible to do these same things with the components that we create. So let's see how to do this. The first thing we're going to look at is inputs. Basically, what inputs allow us to do is pass data into our components from their parent components in a way that looks almost identical to defining attributes on simple HTML elements. In our case, let's say that on our edit listing page, we want to be able to pass in an input to our listing data form component that defines what text is displayed in the form's button. Something like this, for example. We could say button text equals save changes. Well, in order to make this work, we have to go into our listing data forms TypeScript file. And up at the top, along with component and on init, we're going to import something called input. And then down inside the body of the component, we're going to use this funny looking syntax to define an input called button text. So we'll say at input with parentheses after it, button text. And then inside our listing data forms HTML file, instead of having this create listing text hard-coded here, we're going to use our double brackets and say button text. And now if we go back to our edit listing page here, we see that it says save changes, which is the prop that we passed through from our edit listing page components HTML. So that's the very basics of inputs there. What about outputs? Well, here's how we do that. Inside our listing data forms TypeScript file again, we're going to import two more things up here. One is going to be output, and the other is going to be event emitter. And we'll save that file. And we're also going to want our listing type, import listing from types. And then in the body of our component, we're going to define a new output called onSubmit, which will look something like this. We'll say at output with parentheses after it, onSubmit equals new event emitter of type listing. And then we need to change the name of this component's onSubmit method to something like onButtonClicked or something like that. And instead of displaying an alert and navigating inside this method, we're going to simply say this.onSubmit, which is the output we just defined, .emit. And we're going to define the data that we want to send to whatever component is listening. In our case, it's going to be ID null. Name is going to be the current value of the name input. The description is going to be the current value of the description input. And the price is going to be the current value of the price input converted to a number, since that's what we defined in our TypeScript file. And what this will do again is allow parent components to use the parentheses syntax in their HTML files to tap into whenever this component calls onSubmit.emit like this. And we'll see how this works exactly, but first we have to go back into our listing data forms HTML file. And up here, we're going to change this from onSubmit to onButtonClicked, since we changed the name of that method there, remember? And that should be all we need. Now what we can do is go into our edit listing component and connect the output we just defined to our edit listing page's own onSubmit method. So here's what that'll look like. We have our button text input, and we're going to say onSubmit. This is how we tap into that output there. And whenever we receive an onSubmit action, we're going to say onSubmit and call our component's own onSubmit method, which we defined. We have to open up our edit listing page TypeScript file. And actually, we haven't defined it yet. We're going to have to define a method called onSubmit. And what this is going to do is just display an alert saying saving changes to the listing. And then it's going to say this.router.navigate by URL / My Listings. We're going to go back to the My Listings page after the alert is displayed. And then we have to actually import the router. Import router from Angular /router. And provide that in the constructor here. Private router router. And this should work now. If we go back to our edit listing page and click on Save Changes, we should see that it now says saving changes to the listing, which means that the event, the submit event from this form here, is sort of bubbling up to our edit listing page and being handled by this onSubmit method that we just defined. And while we're at this, let's make these same kind of changes to our new listing page component to make it use our new listing data form component. So we're going to open up our new listing page component, and we're going to delete this form and add the app listing data form component with a button text input that says create listing and an output that taps into the onSubmit output of the listing data form and calls this component's own onSubmit method. And inside the TypeScript file for our new listing page, we can delete these things since we no longer need them. And let's make sure that all works still. So let's go into our Create New Listing file, just click on Create Listing. It'll say creating a new listing, which is exactly what we want, and it'll navigate back to the My Listings page. So this is all working great so far, but the last thing that we want to do for our edit listing page is to set the initial values of the form's fields to the current values of the selected listing, right? So when we click on the bicycle listing here and click edit, it should populate that with bicycle and the item description and price so that we can see what actual changes we're making to the item we're editing. So the way that we're going to do that is by adding 3 more inputs to our listing data form component. I'm just going to clean up all these tabs here, and we'll open up our listing data form component again. Open up the TypeScript file. And up here above our member variables, we're going to define 3 more inputs. We're going to have an input called current name, an input called current description, input current description, and an input called current price. And then what we're going to do is inside our ng-on-init method of our listing data form, we're going to say this.name equals this.currentName, this.description equals this.currentDescription, and this.price equals this.currentPrice. So basically, we're just setting the initial values of our text inputs to whatever gets passed in through these inputs here. And just one more thing is we're going to want to add default values for these inputs in case the parent component doesn't pass those in. So we'll just make that an empty string for all of these. And now what we're going to do is open up our edit listing page, open up the TypeScript file and the HTML file, and then inside the TypeScript file, what we're going to do is find the appropriate listing based on the ID URL parameter, this one up here. This is pretty much the same that we've seen in several other components. So what we're going to do is say import activated route, and we're also going to import our listing type, import listing from types, and we're going to import our fake My Listings from fake data. And then inside our constructor, we're going to say private route, activated route. And inside our ng-on-init method, we're going to get the ID from the URL parameter. So const ID equals this.route.snapshot.parammap.get ID. And then we're going to say this.listing. We actually have to define that listing member variable first. We're going to say listing, and then say this.listing equals fake mylistings.find, and find the My Listing whose ID matches the ID URL parameter. And then, last but not least, what we're going to do is we're going to go into our edit listing pages HTML file, and we're going to pass the listings data into the inputs that we defined on our listing data form. So that'll look like this. We're going to have square brackets for these. I'll explain why that is in a second. So we're going to say current name equals listing.name, current description equals listing.description, current price equals listing.price, and that's it. Now, the reason we need these square brackets is because we want to pass the actual values of these variables through to the inputs. In our case, since these are all strings that we're passing, this would be pretty much the same thing as if we had just said current name equals listing.name with curly braces. But in the case that we want to pass through some other type of data, like an object, the way we do that is by putting square brackets around the input name and then just referencing the member variable that we want to pass through. So now, if we go back to our edit listing page for one of our listings, we'll see that it automatically fills the field with the current values, which is exactly what we wanted it to do. So we've got the basic framework for all of our pages set up at this point. The last piece of the front end we're going to create now is the nav bar. This will be a very simple component that's going to be displayed regardless of the route the user is currently on. We'll see how to do that in a second. First, let's start off by creating our component. And to do that inside a terminal, we just have to run ng generate component navbar and hit enter. And this will generate the necessary files for us. The only one we're going to need to edit here will be the HTML file. So let's open that up. navbar.component.html. And we're going to add some stuff to it like this. We're going to say div id equals top bar. And we're going to have a link, router link, and it's going to link to our listings page. And what this is going to be is the heading of our application. So we're just going to have an h1 heading with the ID app heading. Again, that's for styling purposes. And we're going to make that say buy and sell. And then we're going to have another link that links to the My Listings page. So we're going to say router link equals my-listings. And this is going to be a button with the ID of My Listings button. And inside that, it's just going to say My Listings. And we'll save it. So that's all we need for our nav bar. Now what we're going to do is put this component inside our app component. So let's open that up. We're looking for app.component.html. And what we're going to do is above our router outlet, we're going to say app navbar, which will insert our navbar into the HTML of our app component. And lastly, for styling purposes, we're just going to add a few more divs here. We're just going to say div id equals page wrap, div id equals max width column, and we're going to put our navbar and router outlet inside this div. And then surrounding our router outlet, we're going to have one more div that says ID content wrap. And we'll put our router outlet inside of there. And that's it. If we look at our app now, we'll see that it's looking really good, and we can click both parts of our nav bar to get to different places in our app. So we can click our My Listings button here, and it'll take us to our My Listings page, and we can click the buy and sell heading up here, and it will take us to just our regular listings page. Now that we've got our client side working nicely, it's time to start building the back end of our blog. And to do this, we're going to be using Node.js. Now, you've probably heard about Node.js by now, and it's very important to us because it allows us to write our backend in JavaScript instead of PHP or Python or Java. Now, it used to be that in order to be a full-stack developer, you had to be fairly fluent in more than one programming language. But with Node.js, which has become an incredibly popular platform since it was released, our entire web application can be written in JavaScript, which is great news for us JavaScript developers. Now, there are many different NPM packages that can be used to write Node.js servers, and the one that we're going to use in these videos is called Happi. Happi is a good choice for us because it's popular, it's easy to get started with, and it's also very well documented. And additionally, there are a ton of add-ons that can be used to extend its functionality, which, as you'll see later on, really comes in handy. So without further ado, let's get started. To get started creating a backend for our app with Node.js and Happi, let's create a new directory outside of our frontend directory. Since our frontend code is in a directory called buy and sell, we're going to call this directory buy and sell backend. So we're going to click new folder and say buy and sell backend, and click create, and then open. And just as a side note here, in theory, we could have the backend code inside our original directory, but in practice, it's usually just easier to keep the front end and back end code of our app separated, especially as our code base gets larger and more complex. So inside our directory, let's open up a terminal, and we're going to create a new npm package by typing npm init-y and hitting enter. And once we've done that, let's install Happi into our project by saying npm install @happy/happy and hit enter. And then we're going to create a new directory inside of our project called source, and inside of that, we're going to create a new file called server.js. This file will be the entry point for our app, but before we write any code in here, there's something we need to do first. You see, currently, Node.js doesn't have native support for JavaScript's modern ES6 syntax and things such as import and export, so we'll have to make a few small changes to allow us to write our backend using modern JavaScript. We didn't have to do this for our front end because this is something that the Angular scripts take care of when we create a new project. So anyway, the first thing that we have to do is install a few packages from Babel, which if you haven't heard of it before, it's a transpiler that allows us to write our codebase in modern JavaScript syntax and still have it work on systems where modern JavaScript isn't supported natively. So in our terminal, we're going to run npm install --save-dev @babel/core @babel/node @babel/preset-env and @babel/plugin-transform-runtime and hit enter. And once that installs, there's one more Babel package that we want to install. So we're going to say npm install @babel/runtime, which is just the production version of one of the other packages that we installed for development. So the next thing that we're going to do is create a new file in the root directory of our project called .babelrc. So .babelrc. And this is basically where we tell Babel how we want it to transform the modern JavaScript code that we write into JavaScript that Node.js can execute. Fortunately, this is pretty simple. This is going to be a JSON object, and the first property is going to be presets, and that's going to have an array, and the only thing in that array is going to be @babel/preset-env. And then we're going to have another property that's called plugins, and this is going to be an array, and inside that we're going to have another array that'll have @babel/plugin transform-runtime and an object containing the property regenerator true. Don't worry too much about this stuff. It's basically just boilerplate code that will make it so that our server will run correctly. So we're going to save that file, and now we're free to start writing our app in modern JavaScript. So let's go back to our server.js file here, and we're going to write our first bit of server-side code. We're going to start off with an incredibly simple Happi server that just sends us a message when we send a request to it. So the first thing we're going to have to do is import Happi. We're going to say import Happi from @happy/happy. And then setting up a basic Happi server looks something like this. This is just boilerplate code. Don't worry too much about the details here. We're going to say const and create a function called start. And this is going to be an async function. And inside there, we're going to create our server by saying const server equals happy.server. And then we pass it a configuration object, which contains the port that we want our server to run on. In our case, that'll be 8000. and the host that we want it to run on, which in this case will be localhost. And once we've created the server, we're going to say await server.start, which will start up our server. And then we're simply going to log something to the console saying server is listening on, and then we're going to say server.info.uri, which will give us the basic path to access the server from. And now that we've created this start function that we can call to start up our server, what we're going to do is add another thing here that says process on unhandled rejection. This will just listen for unhandled rejections in our Node server. And we're going to give it a callback where we simply log out whatever error happened. So console.log error and process.exit with exit code 1. And last but not least, we're going to call the start function that we created here to start up our server. So let's save that for now. So now that we have this server set up to run, we can define different endpoints and what we want it to do when one of those endpoints is hit. So let's start off very simply. Let's make it so that when our app receives a GET request on an endpoint /hello, it simply responds with a message saying hello. Now to make our Happi server do that, all we have to do is this. Before where we say await server.start, we're going to say server.route, and then pass a configuration object for the route we want to define. This will contain a few properties such as method, which is the method that we want this to listen for. We're going to say get, and then the path that we want it to listen at, we're going to say /hello, and then we're going to define a property called handler. Now, this handler property is a callback that'll get called whenever our server receives the correct type of request on the endpoint that we specified in this path property. Now, this callback has two main arguments. It has a request object, which contains details about the requests that we received, and then it's got what's called a response toolkit, which just by convention uses the letter H. We can use this argument to customize the response we send back to whoever sent the request in the first place. And for now, we're not going to be using either of these arguments, but we'll see how to do so very shortly. Now, the key thing to note for our handler is that whatever we return from our handler will be sent back to the client as the response. So for example, we could say return, and then the string hello, and what this will do is send back a response to the client with the string hello. And for those of you who might be wondering, when we just return a response like this, Happi automatically provides a 200 status code on our response. If you wanted to set your own custom status code, that would look something like this. We could say return h.response, hello, and then say .code, and then whatever code we wanted to send back. But for now, we don't need all of that. A 200 status code is fine. And that's all there is to it, really. All we have to do now is have Node.js run our Happi server. So let's open up a terminal here. And since we're using Babel to run our server, the command that we use for this isn't going to be just node source/server.js. Instead, we're going to use the command npx babel node source/server.js, and then we'll hit enter, and we'll see the message from the callback telling us that the app is listening on port 8000. And now all we have to do is go to our browser, type in localhost 8000/hello, and hit enter. And we'll see the response from our Happi server as we hit the hello endpoint with our browser. So as we move forward with our server development, it's going to be very important for us to have an easy and reliable way to test it. So far, just typing the URL into our browser has worked, but for some of the complicated operations we're going to want to implement for our app, this won't quite be good enough. What a lot of people do to test their backend is to develop a feature on their front end first, and then use that to test the backend. But in practice, I've found that it's generally much easier just to develop the front end and back end in isolation, and then bring them together. And that's what we're going to be doing in this course. So, a tool that's used by many developers for doing this sort of back-end only testing is a free piece of software called Postman. So if you don't already have Postman, you can download it from the link that you see here. So once you've downloaded and installed Postman, let's use it to query our backend. So you're going to want to make sure your server is running, and then we're going to open up Postman and make sure we're sending a GET request here to the URL localhost 8000/hello. And just for those of you who aren't familiar with different request types, such as GET and POST, all you need to know for this course is that GET requests, like the one that we're going to be sending here, are usually used to get information from the server, such as in our application, we're going to be getting listings. And POST requests are usually used to modify something on the server, such as when we want to create a new listing or edit an existing listing. And additionally, POST requests have the ability to carry extra information in something called a request body, while the only information that GET requests carry is contained in the URL. And don't worry if you don't quite understand all of this. You'll be able to get along very well without a full knowledge of network requests. So we're going to want to make sure GET is selected there, and then we'll click Send. And we're going to see that we get the same response back here as we got when we used our browser to send a GET request. So that's how to send a GET request to our server. Let's take a look at a quick example of making a POST request to our server. Now, POST requests, as I mentioned before, allow us to pass extra data along to our backend. So why don't we head over to our server file here? And what we're going to do is change this route. We're going to change the method to POST. And what we're going to have this route do is we're going to be able to send our name along to it in the request body, and it'll reply back hello with our name after it. So here's what that's going to look like. If we go back to Postman and set our request to a POST request, we're going to click on this body tab here, which is where we can define what extra data we want to send along with our POST request. And we're going to make sure JSON is selected from this little drop down here. And what we're going to do is send along a simple JSON object with a property that says name, and I'm going to put my name here. And then on our server, in order to access that name, what we're going to be able to do is say const payload equals request.payload. And then we can say const name equals payload.name, and that will get the value of this property that we included along with our request. So what we can do now is change this to use backticks, and we'll say hello, name, and that should be all we need to do. So now let's restart our server. We need to restart it in order to make our changes take effect. And we're going to head back over to here and send this POST request that we've created here. Click send, and we'll see that down at the bottom, we get this response that says hello Sean, or hello whatever your name is. And that's exactly what we wanted. So that's how to test GET and POST requests using Postman. We'll be using this to build out the other endpoints of our backend throughout this course. So what we've seen so far has been a really simple example, but now that we understand the basic mechanics of adding routes to our Happi server and interacting with those routes using Postman, we can move on to making our server do some more helpful things. Now, the first of those things we're going to do is add a listings endpoint for our front-end listings page to load data from. But before we create our routes, let's do what we did with our front end and copy and paste some fake data into our server. Basically, what we can do is just take the fake data from the front end and put it into a new file in our back end. Now, the first thing we're going to do is create a new folder in our source directory. We'll call this routes. And as you might have guessed, this is the directory that will hold all the files for our server's routes. And then inside this routes thing, before we actually create any routes, we're going to create a new file called fakedata.js. And then we're going to copy and paste the data from our front end into here. And since we're not actually writing our server code in TypeScript, let's just remove these types here. And now we're good to go. Keep in mind, of course, that in a little bit we'll be adding database functionality to our server, so we'll only be using this fake data until then. So now let's move on to creating our first real server route. Now, when creating a bunch of different routes for a server, I'd highly recommend that we create a new file for each route. This is usually considered something of a best practice, since it helps us keep all the different routes of our application separate. So for our listings route, let's create a new file inside our routes directory. We'll call it get all listings.js. And then inside it, we're going to define our route. This is actually going to be an incredibly simple route for now. We're going to start off by importing our fake listings from our fake data file. And then we're going to say export const get all listings route equals, and the method for this route is going to be get. The path for this route is going to be /API/listings. And we're going to see later on in the course why exactly it is that we're starting each of our routes with /API here. For now, just make sure to do it. And then for our route handler, we're going to say request and h. And all this route is going to do is just say return fake listings. That's it. Very simple route here. So now that we've defined this route, we need to actually add it to our server. So here's how we're going to do that. Instead of explicitly importing each and every route into our server.js file, I'm going to show you the way that I usually tend to do things. What we're going to do is inside our routes file, we're going to create an index.js file. And then what we're going to do is import the route we just created. So we'll say import get all listings route from get all listings. And then what we're going to do is we're going to export an array that will eventually contain all of our routes. For now, it'll just contain our get all listings route. So we'll say export default get all listings route. And now that we have this, let's save that file and open up our server.js file. And what we're going to do is up at the top, we're going to say import routes from routes, which will import that array we just exported. And then we're going to remove this hello route because we don't need that anymore. And then what we're going to do is we're going to use for each to loop through all our routes and add them to our Happi server like this. We're going to say routes.forEach, and for each route, we're going to say server.route and add our route. So simple as that. Okay, and that should be it. Now if we restart our server, and there's one more thing that I'm remembering in the fake data.js file here. We need to remove this listing array type as well, otherwise we'll get an error. And anyway, now if we restart our server, what we should be able to do is go into Postman, change it to get, and send a request to localhost 8000 /API/listings, and hit send. And we should see that we're getting our fake data back from the server, which is exactly what we wanted. So you may have noticed that until now we've had to manually restart our server every time we make a change to our code in order for those changes to take effect. And wouldn't it be nice if our server could sense when our files changed and automatically restart itself? Well, as a matter of fact, there's an npm package that does this for us, and it's called NodeDaemon. Let's install this package into our project like this. We're going to say npm install --save dev NodeDaemon and hit enter. And once that installs, all we have to do is change the command that we use to run our server. Instead of running npx babel-node source server.js, we're going to write npx NodeDaemon --exec npx babel-node source/server.js. The command is a little longer, but it saves us a lot of work in the long run. And then hit enter. And what we're doing here is telling NodeDaemon to rerun whatever command we put after this exec flag whenever our files change. So in other words, it's going to run npx babel-node source/server.js every time the files in our project change, which is really useful for us. And if we go back to Postman and hit send again, we see that we're still getting back what we want. But if we were to change this route to something, say, just return, here are the listings, or something like that, and then send another request, we see that it updates automatically without us having to manually kill and restart the server. So let's change that back. There we go. And I'll admit that this node daemon command might be a little long to remember, so while we're at it, we're going to make one more small change to our codebase. If we open up our package.json file, we'll see that there's this scripts object with a default test script inside it. Now, you may or may not be familiar with this part of package.json, but these scripts are basically just aliases for longer commands, and we can create our own scripts and call them whatever we want. What we're going to do here is create an alias for our long node daemon command. So we're going to call our script dev, and then for our dev script, we're just going to run npx node daemon --exec npx babel-node source/server.js. And as a matter of fact, we can actually remove this npx here since this is inside our package.json file. And don't forget to add the comma at the end here. And that's it. So now if we want to run this command, what we can do instead of typing the whole thing out is just type npm run and then the name of the script we just created, so dev, and it'll run it for us. And from now on, that's what we'll be using to run our dev server, since it's a lot easier to remember and a lot shorter to type. So far, we've only implemented one route on our server, a route that returns all the listings. And before we move on to actually incorporating an SQL database into our backend, at which point we'll switch our existing routes over to use it, as well as create several more, we're going to see how URL parameters work with Happi servers by creating a route that will allow our front end to request data for individual listings by their IDs. So here's how we do that. First, inside our routes directory, we're going to create a new file called getListing.js. And then inside this file, we're going to create our route. We're going to say import fake listings from ./fake data. And then we're going to say export const getListing route. And this route is going to listen for the get method on the path /API/listings/ and curly braces ID. And it's worth noting that in Happi, we don't use the colon syntax for URL parameters. We instead use curly braces around the name of the parameter. And then for our handler, we're going to say request and h. And the way that we actually get access to the value of this ID URL parameter here is like this. We're going to say const ID equals request.params.id. And then we're going to say return fake listings.find listing, where the listings ID is equal to ID. This is pretty much the same exact thing that we saw on our front end. And now that we've created that route, we're going to go into the index.js file of our routes directory. And we're going to import our getListing route from getListing. And then we're going to export that as part of this array here. So getListing route, like that. And we should have our server running in the background with the new dev script that we created in a previous video. So what we can do now is just go over to Postman and send a request to /API/listings/123 and hit send. And we should see that it returns the corresponding listing. So that's the basics of using URL parameters in a Happi server. So we've created two routes on our server so far, and before we continue on to adding a database and other routes, we're going to take a little detour and look at a very important concept when writing backend code, and that's how to work with errors. So Happi's approach to this topic is a little different than what you might find on a lot of other server-side frameworks, and most of it revolves around an npm package called Boom, which we can install in our project by running npm install @happy/boom and hit enter. Now, this package is our first experience so far with what's sometimes referred to as the Happi ecosystem. You see, one of the really nice things about working with Happi over other possible frameworks like Express is that Happi has a pretty extensive collection of different official modules and plugins that allow us to add in functionality to our server without a whole lot of setup. If you're interested, you can find a list of all these modules and plugins, as well as a lot more information about each of them on Happi's website, which is happy.dev. So anyway, this package in particular, the Boom package that is is used to make it easier to send back error responses to the client. In all of our server routes, if something bad happens during execution, we want to let the client know. And this could be an actual error, such as if the server can't connect to the database, or if we accidentally pushed some code into production that doesn't work. Or it could be something more expected, like if the client is trying to get information about a listing that doesn't exist, in which case we'd want to respond with a 404 error code. Now, without the boom package that we just installed, we'd be forced to set the error codes and other response headers ourselves, which can be a bit of a pain. So what Boom does is it provides us with a suite of very common errors that we might encounter on our server, and when we throw these errors from inside our route handlers, Happi will automatically set the appropriate response headers and status code for us. So that might sound pretty complicated, but it's actually pretty simple. So let's take a look at a demonstration. In order to demonstrate this, let's open up our getListing route and add in some error handling for what to do if the client requests info for a listing that doesn't exist. In other words, if they send us an ID for which we have no matching listing. The first thing we're going to do is up at the top, we're going to import Boom like this. We're going to say import Boom from @happy/boom. And then we're going to rewrite our route handler to look like this. Instead of just saying return fake listings.find, we're going to define an intermediate variable here. So we're going to say const listing equals fake listings.find and find that matching listing. And then underneath that, we're going to say if that listing doesn't exist, and actually we want to call this listing instead of listings. We're going to say if that listing doesn't exist, throw boom.notfound with a message that we can define. So for this, we're going to use backticks, and we're just going to say listing does not exist with ID, and then just insert the ID that the user sent. So what's going on here is when we want to respond to the client with an error code, such as 404 in this case, we simply use the throw keyword and then use the appropriate boom error. In this case, we're using not found, but there are many others to choose from for different situations. And once we've done this, Happi takes care of the rest. So the last thing we want to do in this route, now that we have that error set up, is we're just going to say return listing if the listing does exist. So let's save this, and our server should be running still. And now if we try and send a GET request to API/listings/ and then put an ID that doesn't exist, and click send, we see that we get back a 404 response that contains some other information as well, such as the message we passed to the boom.notfound function. So that's the basics of using the boom package to send back error responses. All we have to do is say throw boom, and then the corresponding error that we want to return to the client. And we'll see more examples of boom in some of the other endpoints that we're going to add to our server as well. So now that we have our client side built out and a rudimentary server with a few routes, it's time to start integrating a database into our backend. And this will enable us to store users' data and persist that data indefinitely. In this course, the database we're going to be using is MySQL. Now, MySQL is an extremely popular database management system, and it's also open source, which means that it can be installed and used for free. First of all, as you might have guessed by the name, MySQL uses SQL to make database queries. In practice, SQL queries can get really as complex as you need them to be, but in this course we'll be keeping our queries as simple as possible, so don't worry if you're not already familiar with SQL. This will be a great opportunity to get your first contact with it. The second thing to know about MySQL databases, if you haven't already worked with them, is that they're relational databases. What this means is that the data they contain is structured into rows and columns. Now, rows are basically just individual records, such as users, or in our case, listings. And columns denote the different pieces of data that each record has, such as name, description, price, etc. The data in our database is also organized into different tables, each of which contains records that all have the same column attributes. So we might have a users table that contains all of our website's users, and a listings table with information such as the listings ID, name, description, and price, as well as the user ID of the user who listed it, and whatever other stuff we need to store about each of our listings. Now, you may have heard of a different kind of database called a non-relational or NoSQL database. MongoDB is probably the most popular of these databases. In contrast with relational databases, which is what we're going to be using in this course, non-relational databases primarily store unstructured data. And usually what this means is that instead of storing data in rows and columns, the data in these non-relational databases is just stored in JSON objects. And there are certain trade-offs to doing this, none of which is really going to be relevant for this course. For now, I just wanted you to be aware of the distinction here. At the end of the day, it's best just to try both ways and see which is best for you. But in this course, we're going to be using a relational SQL database. The first thing to do here is if you don't already have MySQL installed on your computer, which is likely the case, we're going to download and install that. And in this video, we're going to see how to do that, as well as download and install another tool that we're going to be using called MySQL Workbench. So the first thing you're going to want to do is go to dev.mysql.com/downloads/MySQL and download the latest version of MySQL. And you're going to want to make sure your operating system is selected from this dropdown here. So I'm going to click download on this DMG archive here. And I'm going to click no thanks, just start my download, because I don't want to create another account now. And once that downloads, let's click on that. And that'll bring up this thing here. Let's click on that. And we're going to click continue. And we're just going to go through each of the steps here. Just click continue, continue, agree, install. Gonna have to put in our password. And that'll install MySQL on our computer. So we're gonna click next and just leave use strong password encryption selected there. Click next. And then it's going to ask us to enter a password for the root user. Basically, the root user on our local computer is going to be the user that's able to do everything with our database, right? They have permissions to do basically anything we need to do. So I'm just going to put in a simple password that I'll remember here, and leave this Start MySQL Server once the installation is complete thing checked. So then we're going to click Finish, and we might have to put in our password again. And then we're going to click Close, and MySQL is now going to be active behind the scenes. So the next thing that we're going to do is install a tool called MySQL Workbench. Basically what MySQL Workbench is a user interface for interacting with our local MySQL databases. And it doesn't just work with local databases either. It can work with basically any MySQL database that we have access to. So in order to download that, we're going to go to dev.mysql.com/downloads/workbench. We're downloading it from the same site here. And then we're going to select our operating system and click download. And again, we're going to click no thanks, just start my download. And once this file downloads, we're going to click on it here. And then we're going to drag it over into our applications folder. If you're on Mac, that's just how Mac does things here. And I actually already have MySQL Workbench installed on my computer, so I'm just going to click Stop, but you probably won't even get that message, so that won't be a problem. So once we do that, let's open MySQL Workbench. And you'll see that we have this local instance 3306 thing up here. That is our local database, and we can connect to it by clicking on this and putting in the password that we put in earlier. And now we're successfully connected to our local MySQL database. So now that we're connected to our local MySQL instance, what we're going to do is set up a database that our backend will be able to connect to and store data in. The first thing we have to do here is we have to actually create a specific database that our backend will use. And the way that we do that is by clicking on this little database thing with the plus sign up at the top here. And we're going to create a new schema, which is basically just a new database that an application can use. So we're going to call this schema buy and sell, just like the name of the site that we've been working on. And we're going to leave the default character set and default collation on, and click apply. And then we're going to click apply here. And we should see at the bottom here that that was successful. So the next thing we're going to do is create a table to hold the listings for our application. In a larger application, our database might have several tables. One for holding listings, one for holding users, one for holding messages, and so on. But for this one, we're just going to have one table called listings. So to do that, go over to schemas, make sure buy and sell is selected, and click the table thing up here with the plus sign next to it. And this can be a little tricky sometimes. You have to double click this schema name here in order for this to work. And we're going to call this new table listings. And then what we have to do is we have to define all of the different columns that we expect our data to have in this database. Essentially, these are going to be all the different properties that our data will have. So the first one is going to be the unique ID, and this will be a 36-character varchar. And we're going to make sure the primary key and not null boxes are checked next to it. And we're also going to check the unique box. And then we're going to have a column that holds the name of our given listing, and we're just going to leave that at 45 characters. In reality, we might want to make that a little bigger, but for our purposes right now, 45 is plenty. And we're going to select not null. And next, we're going to have the description column, and we'll make that a little longer. We'll make that 1,000 characters, and that will be not null as well. Then we're going to have the price, which is going to be a decimal value. So we're going to select decimal. And then we have to specify the number of digits that we want it to be accurate to, as well as the number of digits after the decimal point. So we're just going to put 10 and 2 there. In reality, we might want to put something different, but that'll work for now. And then we're going to have a user ID column representing the unique ID of the user that this listing belongs to. And that'll be a varchar of length 36 as well, and that'll be not null. And last but not least, we're going to add another column to this database that our fake data on our backend didn't have, and that's going to be called views. What we're going to be doing is we're going to use this property to count how many times each listing has been looked at by users of our site. And for this one, we're just going to select int, and we're going to have that be not null as well. And the default value for that, we'll put 0. And that should be all we need to do for now. So now if we click on apply here, and then click apply, we should see that our SQL statements were successfully executed. So we can click close now. And the last thing we're going to do is, now that we have our listings table created, we're going to insert some data into it. So the way that we do that, this is the first real SQL statement that we're going to see, is we're going to say insert into, and then the table that we want to insert this data into, which is going to be listings. And then inside parentheses, we're going to put the columns that we want to insert the data into. So we're just going to say ID, name, description, price, user ID, and views. And close the parentheses. And then we're going to say that we want to insert the values. And then we're going to insert several records, each of which is going to be enclosed in parentheses like this. So we're going to say 1, 2, 3. The name is going to be guitar. For the description, we'll just type something there. Then we'll put the price. And then the ID of the user that this belongs to, we're going to say 1, 2, 3, 4, 5 here. And last but not least, the number of views. And then we're going to insert a few more records, which you're free to copy and paste from the exercise files. And once we have all of that, we're going to click on this little lightning bolt icon up here, which will execute our MySQL statement. And down at the bottom, we should see that that turns green. And now what we can do is get all of our listings from our table by typing select star from listings and hitting this lightning bolt icon again. And that'll give us the result, which will show all the things that we just inserted into our database. So now we have MySQL installed and set up with a working database, which is pretty exciting. But this won't actually do us any good yet until we know how to connect to it from our Happi server. And this is actually a fairly simple process, so let's take a look at how it's done. The first thing we have to do is to install the MySQL npm package into our project, which we can do by running npm install MySQL and hitting enter. And next, we're going to create a new file in our source directory. And we're going to call it database.js. And this is going to contain the logic for setting up a database connection. So here's what that'll look like. We're going to start off by importing the MySQL driver like this. We're going to say import MySQL from MySQL. And then we're going to create a connection that our server can use to communicate with the local database we created previously. Here's what that'll look like. We're going to say const connection equals MySQL.createConnection. And then we're going to pass a configuration object to it. We're going to say host, localhost, and user is going to be the username that our server is going to log into our MySQL database with. So what we're going to do is we're going to define a new user at some point. We'll call it Happi server. We'll have to come back to that later. And then for the password, we're just going to say something like this. We'll have to remember that and define that on our database as well. And then for the database name, we're going to put the name of the schema that we created earlier. And that'll be buy and sell. And that should be it. So what we're going to do now is we're going to export an object from this file that sort of abstracts away a lot of the complexities behind working with the MySQL driver. So we're going to say export const db, and this db object is something that the rest of our application will use. And the first property of this object is going to be a function called connect that our server can call to establish a connection with the database. And we'll see how and where to do this shortly. So we're just going to say connect. And then say connection.connect. And the next thing we're going to define is a property called query, which will be a function that wraps MySQL's provided querying functionality. Now, what we're going to do here might be a little bit technical for those of you who aren't familiar with promises and async await, but basically the MySQL driver currently only allows us to use callbacks to handle query results. In order to allow ourselves to use async await, which in my opinion is much nicer, what we're going to do is we're going to convert that functionality into a promise, which means that we'll be able to use the await keyword with it. So here's what that'll all look like. And again, don't worry, this is going to be a little bit technical, but this is the only place in the course where we're going to have to do this. So we're going to say query, and then it's going to take two arguments, query string and escaped values. We'll discuss these later on in the course. And then what we're going to do is we're going to return a new promise with resolve and reject arguments. And then inside here, what we're going to do is we're going to say connection.query, and we're going to pass the query string and the escaped values through. And then we need to pass the callback, which will basically just take the results and fulfill the promise with them. So this callback is going to take error, results, and fields arguments. And then inside this callback, we're just going to say if error, then we want to reject the promise with that error. Otherwise, we want to resolve the promise, passing the results and fields through. And again, don't worry too much about the details here. All we're doing is converting the MySQL query function into a promise. And finally, the last thing we're going to do here is we're going to return an end function that should be called when our server shuts down. So we're going to say end, and this will simply call connection.end. So now that we've created this database wrapper thing, let's see how to use it on our server. All we have to do is open up our server.js file, and we're going to import the database object we just defined. So we'll say import db from /database. And then down in here, we're going to connect to our database right before we call server.start. So right here, we're going to say db.connect. And then what we need to do is close our database connection when the server is killed. And here's how we do that. You see, when we first set up our server, we coded this unhandled rejection listener thing here, which gets called when an unhandled error occurs in our server. And we're going to add another one of these callbacks for when we kill the server manually. So here's what that'll look like. We're going to say process.on, and then all in caps, sigint. This is basically just when we press Control-C to kill our server. And then we're going to define a callback that'll get called when that happens. And inside here, we're just going to say console.log, stopping server. And then we're going to say await server.stop. And we need to pass an object here with the property timeout, which will tell it how long to wait before it forces the server to quit. And then underneath this, we're going to call db.end, like that. Now, the only other thing is, in order to refer to the server inside this callback, we actually have to go up here and say let server up at the top of our file. And instead of saying const server here, we're just going to say server equals happy.server. This will allow us to use server down here in our callback. Anyway, after we've called db.end, we're just going to say console.log server stopped, and then say process.exit with the exit code 0. Now that we have our server set up to connect to the database on startup and then close that connection when the server is killed, let's move on to seeing how to make actual database queries from our routes. To demonstrate this, what we're going to be doing is rewriting both our getAllListings route and our getListing route to query the database and then send back that data to the client instead of the fake data that we've been using so far. So let's start off with our getAllListings route. The first thing we're going to do here is import the DB object that we exported from our database file. So we'll say import DB from ... database. And then we're going to modify this route handler here. Instead of returning fake listings like we've been doing, we're actually going to make a query to our database using the query function of the database object we just imported. So here's what that'll look like. We're going to say const results equals await db.query. And then as an argument for this db.query function, we're going to pass a MySQL query string. This will be our first real contact with MySQL inside our server here. So again, if you're not already familiar with MySQL, don't worry too much about the details here. What we want to do is retrieve all of the listing records from the listings table we created. And the query for that is going to look like this. We're just going to say select star from listings, and that's it. So that's how we load all of our listings from our database. And we also have to add the async keyword to this route handler function since we're using await inside of it. And then the last thing we're going to want to do here is return all of our results, which will send them back to the client. So we'll say return results. And we can also delete this fake listings here, since we don't need that anymore. So now if we use Postman to make a request to this endpoint, we'll say get localhost/API/listings and click send. And it looks like I forgot to add the async keyword here as well, so we just need to add that async keyword to the callback that gets called on process.onSigint. And one more thing that I almost forgot is that we have to actually create this user for our database in order for our server to connect to it. So what we're going to do is go back to MySQL Workbench, and we're going to go over to this administration tab here and click on users and privileges. And then we're going to click on add account down at the bottom here. And for the login name, we're going to use happy-server, which is what we put here for the username. Authentication type standard. We're going to leave that as the %sign there. And for the password, we're going to use the password that we put in here, even though it'll tell us, of course, that it's a weak password. And we're going to click apply. And that should create the new server for us. And the next thing we have to do is we have to go over to schema privileges and click add entry. And we're going to go down to selected schema here and select our buy and sell schema, since we only want the permissions here to apply to that. And then what we're going to do is we're going to give our server certain rights. So we're going to say it's allowed to insert, it's allowed to update, it's allowed to select, it's allowed to delete. And that should be about all we need for our server. So now we're going to click apply. And that should be all we need to do. So now let's go back and restart our server. So npm run dev. And we should see that our server successfully connects and is running now. So if we go over to Postman now and try and send a request to /API/listings and click send, we should see that we get back all of the listings from our database. So that's how we add MySQL to our get all listings route. Now let's take a look at how to add it to our route for getting individual listings. So for that, we're going to click on get listing. And again, we're going to start off by importing our database object, import DB from database. And we can delete this fake data here. And then the first thing we need to do is we need to make the route handler async, since we'll be using the await keyword, just like with our other route. And then instead of using the fake listings here, we're going to use our database object to load the corresponding listing from our local database. And this query will look a bit different here, so I'm just going to type out the whole thing and then I'll explain it afterward. What we're going to say is const results equals await db.query. And then for the query string here, we're going to say select star from listings where, this is where we add a filter to it, ID equals question mark. And then we're going to put a comma and add a second argument to our db.query function here, which will be an array containing the ID that we get from request.parameters.id. So what we're doing here is we're selecting the listing from our listings table with the ID that the client requested. And this question mark thing here is how we insert the values of variables into an SQL query in Node. When we make this query, what will happen is that each question mark inside the query string will be replaced one by one with the values we provide inside this array that we're passing as the second argument. Now, you might be wondering why we need to do it this way. Why can't we just do something like this, where we just say plus ID, right? Well, the answer is that doing it using the question marks prevents hackers from using something called SQL injection to attack our database. And for those of you who aren't familiar with SQL injection, basically SQL injection is when hackers pass clever values to the variables that we're inserting into our SQL queries. So for example, instead of using an actual ID in the query that we're sending to API/listings/ID, they could say something like API/listings/ and I'm just going to paraphrase here. The real URL would look slightly different. They could say drop table listings, for example, as the ID property. And what this would do is that if we were just inserting this raw string into our SQL here, it would actually delete our listings table. So basically, using this question mark thing, instead of just randomly inserting values into our SQL queries, prevents this kind of thing from happening by inserting the values properly. So anyway, now that we have our results from that query, which is going to be either an array with a single element, since listing IDs are unique, or it will be an empty array if the listing doesn't exist, what we can do is we can just say const listing equals results index 0, and then the rest of our code will still be valid here. We just want to return the listing if it exists. Otherwise, we'll use the boom package that we saw earlier to return a not found response to the client. So now if we test this by saying /API/listings/123, or any of the other ones that we see down here, and click send, we should see that we just get back an individual listing from our server endpoint. And if we try and do SQL injection here, which would look something like this, which I'm just going to copy and paste, and click send, we'll just get something that says listing does not exist with ID, drop table listings. And one more thing to note here too about Happi servers in general is that in the event that some error happens on our endpoints, for example, if they can't connect to the database or something like that, Happi will automatically send back an appropriate response with a 500 error, which is just the generic way of saying that something went wrong on the server. So unless we really want to implement a separate response for cases like these, we're fine to just leave our route handlers without a try-catch block. So we've seen the basics of querying our database now, and our server is able to load listings from our database and send them back to the client. The next thing we're going to add to our server is an endpoint for keeping track of how many times each listing has been viewed. Now, we actually haven't built this into our front end yet, we'll get to that in a little while, But what we want at the top of each listing page is a little message that says something like, this listing has been viewed 125 times, for example. And of course, we'll want to increment this number every time someone visits the page. So in order to implement this functionality, what we're going to do is inside our routes folder, we're going to create a new file, and we're going to call it add view to listing.js. And inside that, we're going to define a route that looks something like this. We're going to import our database object from /database. Then we're going to say export const add view to listing route. And then for the method, this is going to be a post route. All we've seen up until now have been get routes, but this one's going to be a post route. And we're going to say path is going to be /API/listings/ID in curly braces /add view. And then for the handler, this is going to be an async callback. And we're going to say request and h. Then we're going to say const ID equals request.params.id. That'll get the ID from the URL here. And then we're going to make a query to our database to increment the number of views on the listing whose ID matches this ID here. And that'll look like this. We're just going to say await db.query update, and then the table name listings. And we're going to say set views equals views plus 1. And we want that to happen where the ID is equal to, and we're going to use the question mark thing there to insert the value of the ID. And then we're just going to have an array with the ID as a member. And again, if you're new to SQL here, don't worry too much about this one. All we're doing here is saying that we want to increment the number of views on the listing with the ID matching the ID URL parameter. So the next thing we're going to do here is that it's pretty common for routes that update data to send back an updated version of whatever data was modified. So what we're going to do is get the updated data for the listing whose views we incremented. And to do that, we'll say const results equals await db.query select star from listings where ID equals question mark. And then we're going to insert the ID URL parameter just like we did before. And after that, we're going to send that updated listing back to the client. So we'll say const updated listing equals results 0. And we're going to say return updated listing. And it would help if I spelled that right. There we go. And we're not being super careful about error handling here. For example, we're not really defining what we want to happen if this ID doesn't correspond to a listing in our database. But that's a pretty easy thing to do, so if you want, you can always go back and do that. But for the sake of time here, we're just going to move on. And now that we've defined that route, we're just going to export it from our routes index.js file. So we're going to import it. We're going to say import add view to listing route from add view to listing. And we're going to put that in the export default array, add view to listing route. And actually, now that I think about it, one last thing that we're going to want to do here is go back to our front-end code and add the views property to our listing type. So let's open up our types.ts file here. And remember that we didn't have this views field in our fake data that we've been working with so far. So what we're going to do is we're just going to say views number. And this will break our fake data file. So what we're going to do is we're just going to go through and add views 0 to each of these. Not that this will even be relevant, since we'll be replacing this with actual server calls, but for now, we're just going to do that to avoid errors. And make sure to save both those files. So anyway, going back to our add view to listing endpoint, what we should be able to do now is send a post request to API/listings/ we'll just do 123 /add-view, and click send, and it'll send back the updated version of that listing with the views incremented. And we can click it a couple times if we really want to see it working. So that's the endpoint for adding views to listings. The next endpoint we're going to create is the endpoint for getting all of the current users' listings. And this endpoint will be called by the My Listingspage on our front end. So here's what this is going to look like. Inside our routes directory, we're going to create a new file. And we're going to call it get user listings.js. And we're going to import our database object from database. And we're going to say export const get user listings route. And the method for this is going to be get. The path for this is going to be /API/users/ in curly braces user ID /listings. And finally, for the handler, we're going to say async request h. And the first thing we're going to do inside this route handler is get the user ID from the URL parameter. So we're going to say const user ID equals rec.params.userid. And underneath here is where later on we're going to check to make sure that the client requesting this data is actually the user with this ID. Otherwise, what we'll do is we'll return an error saying that the user isn't authorized to get this data, since we only want users to be able to fetch their own listings and not the listings of some other user. And granted, in our application, this wouldn't be that big of a deal since users can see all of each other's listings anyway, but still, that's just something to think about. So after that, what we're going to do here is get all the listings in our database with their user ID property equal to the ID of the user that requested it. That is this user ID URL parameter here. So we're going to say const results equals await db.query. And for the query string, we're going to say select star from listings where user underscore ID equals question mark. And then we're going to insert the value of the user ID variable up here. And then all we have to do is send back the results to the client. So we'll just say return results. So that's it for defining the route. We just have to export it from our index.js file now. So we're going to say import get user listings route from get user listings. And then we're going to export it along with our other routes, get user listings route. And now, provided our server is running, we should be able to send a request to API/users/12345/listings and hit send. And if you forgot to change this from post to get like I did, you'll see 404 not found. But if we change it to get and click send, we'll see that it returns all of the listings that belong to the user ID 12345. Okay, the next route we're going to create is the route that will allow users to create new listings. And this will be hit when the user fills out the form and hits the create button on the new listing page. So the first thing we have to do here is install a package called UUID. We'll be using this package in our route to generate random unique IDs for the new listings that users create. So we're going to say npm install UUID and hit enter. And just a note about this package. Depending on the version of Node.js you're using on your computer, this package may throw a weird error for you when you try and use it on our server. In particular, version 13.5, which is the version I showed you that I was using back at the beginning of the course, was causing problems for me, so I had to switch back to using version 12.18 here. And keep in mind that the latest versions of Node would probably work as well, but just so you know, if you get a weird error here, that might be why. So anyway, now that we've got that package installed, let's create a new file in our routes directory. And we're going to call it create new listing.js. And then at the top, we're going to say import v4 as UUID from UUID. That's just how we import the function that we're going to be using there. And then we're going to say import and import the DB object from our database file. And then to define the route itself, we're going to say export const create new listing route. And the method for this one is going to be post. This is going to be a post route. And the path will just be /API/listings. And then we'll define the handler, which just like the others will be async. So async request H. So we're going to start off here by creating a new random ID for the new listing. To do that, we just have to say const ID equals UUID. And then we're going to get the data for the new listing that the client sent along with the request. So we need to get that out of the request payload like this. We'll just say const name, and we're going to be providing default values for all of these, by the way, in case the client forgot to send one of these. And then description and price equals request.payload. Remember that this is how we get the payload from a post request. And once we've done that, we're going to need the user ID so that we can add it to the new listing here that we're creating. For now, we're just going to hard code that like this. We're going to say const user ID equals 12345. But later on, we're going to be using authentication to make sure we really know which user is making this request. And once we've done that, we're going to say const views, and the starting value for that will be 0. And that's all the data we need. Now for the query, it's going to look like this. We're going to say await db.query. I'm going to use backticks here because I want this to be a multi-line string because it's going to get a little bit long. We're going to say insert into listings, and then the names of the columns that we want to insert our values into. That'll be ID, name, description, price, user underscore ID, and views. And then we're going to say values along with the values that we want to insert. So we're just going to say question mark, question mark, question mark, question mark. That'll be 6 question marks in all. And as the second argument to our query function, we're going to pass in the ID, name, description, price, user ID, and views variables that we defined. And then what we're going to do is now that this new listing has been created inside our database, instead of actually querying it from our database, we're going to return the relevant data from the listing that was just created, which we can do simply by using all these values that we defined up here. There's no need to query the actual data from the database this time. We're going to say return ID, name, description, price, user ID, user ID. We just have to do that there because we don't like to use underscore names as variable names in JavaScript. And then views. And now that we've created the route, we just have to export it from our routes index.js file. So we're going to say import create new listing route from create new listing. And we're going to add that here, create new listing route. And now what we can do is we can test our route by sending a post request with the correct body to the endpoint we just created. So we're going to send a post request to API/listings. And we're going to want to define the request body here. So we're just going to say name, and we'll just give our new listing a name. We'll say air conditioner, something that you see fairly often on listing sites. And then for the description, we'll just say something like this. And for the price, we'll have it be $100. And now if we click send, we should see the data from the new listing that was just created with this randomly generated user ID up top and all the information we provided. And now if we simply send a GET request to API/listings, we should see that the new listing that we just created is part of that. Okay, so we're getting to the end of our server routes. The next one we're going to create now is a route that will allow users to edit their listings. So let's get right down to business and create a file for it. We're going to call this one updatelisting.js. And then we're going to define our route. So we'll say import db from /database, and then export const. We're going to call it update listing route. And this will be a post route, so we'll say method post. The path for this route is going to be /API/listings/ID in curly braces. And then we have the handler, which, like all of our other ones, is going to be async. So what we're going to do first is we're going to start off by getting the ID from our URL parameters. So we'll say const ID equals rec.params. And then we're going to get the updated name, description, and price values from the request payload. So we're going to say name, description, and price equals request.payload. And then just like we did in our create listing route, we're going to hard code the user ID for now. So we'll say const user ID equals 12345. And note that at some point, we'll also want to check to make sure that the client sending this request really is the one who created the listing. Otherwise, users would be able to edit each other's listings. So now we come to the query, which is going to look something like this. We're just going to say await db.query. And I'm going to use backticks for this one since it's going to be another multi-line query. We're going to say update listings. And this is just how we update things in MySQL. So we're going to say set name equals question mark. We'll be inserting that later. Description, price, and then we're going to say where ID equals question mark and user ID equals question mark. We're going to make sure that both the listing ID and the user ID match on that listing, which will help when we're actually using real user IDs here. And then for the second argument to our db.query function, we're going to pass an array with the values name, description, price, ID, and user ID, which will fill in all of the question marks in this query string. And then what we're going to do is we're going to get the updated listing from our database and send it back to the user, which is going to look like this. We're just going to say const results equals await db.query. And we're just going to say select star from listings where ID equals question mark and user ID equals question mark. And then we're going to insert ID and user ID into that query. And finally, we're going to say return results index 0, since this results will only ever contain one result. And then we're going to go and export this from the index.js file. So we'll say import update listing route from update listing. And then down here in the array, update listing route. And now that we've done that, what we can do is we can go back to Postman and send a post request to /API/listings/ and then the ID of the listing that we want to change. In our case, we'll use this one that we just created. And for the body, we're just going to make a nice simple change. And let's say we want to increase the price. And now if we click send, we should see that we get the updated version of our listing sent back to us. And if we send a GET request to the same path, we should see that that was indeed updated on the server, since this is now being returned to us from the server. So now we've come to our last route, and that's the route that will allow users to delete listings. So here's what that'll look like. Let's create a new route file called deletelisting.js. And then we're going to implement the route like this. We're going to say import db from /database, and then export const delete listing route. And the method for this route is actually going to be delete, which is just another method that the client can send like get or post. And the path is going to be /API/listings/ID. And then for the route handler, it's going to be async And inside there, we're going to get this ID URL parameter by saying const ID equals request.params. And just as a side note, at some point here too, we're going to want to check to make sure that the client who's sending this request is actually the owner of this listing, because otherwise users would be able to delete each other's listings, which obviously wouldn't be ideal. But for now, what we're going to do is we're just going to make the query. So we're going to say await db.query. And for the query string, it's just going to look like this: delete from listings, where ID equals question mark. And for the ID, we're going to pass the value of the ID URL parameter. And then at the end of the route handler, we want to send something back to the client. Now, what we could do is send the info for the listing that we just deleted back to the client, but all we're going to do in this case is just send back an object with a message that says success, just like that. And now let's export this route from our index.js file. So we're going to say import delete listing route from delete listing, and export that along with the rest of our routes. And now we should be able to send a delete request to API/listings/ and then this big long ID of the listing that we created, and click send. And we should just get back message success as a response. And now if we try and get this listing and click send, it'll send us back 404 not found, and we'll see the message that we defined earlier: listing does not exist with the ID. So at this point in our app, we have a fully functioning front end and we have a fully functioning back end. What we need to do now is link them up, and that's what we'll be doing over the course of the next few videos. Now, there are a few tools and tricks to getting this sort of front-end, back-end communication to work properly, but before we get into all of those, we're going to take a look at something called services in Angular. Basically, Angular services are like Angular components, except they don't have any corresponding HTML that gets rendered on the page. So then, if services aren't rendered to the page, what exactly do we use them for? Well, the main thing that we're going to be using services for in this course is as a place to put the logic for communicating with our server. You see, the way that we have our front end set up now, all of our components are only displaying fake data. For example, in our listings page component, we're just saying this.listings equals fake listings that we defined inside our fake data file. Obviously, however, now that we have our backend set up, we'll want the data that each of our components displays to be loaded from our server. Now, one possible way of interacting with the server from our front end would be to simply include all the logic for doing so inside our components themselves. So for example, we would fetch our listings here. However, this is generally not a good idea. First of all, it reduces code reuse in our codebase, and second of all, adding all of the raw logic for interacting with the server to our components can dramatically increase the size of our components, making our codebase less and less maintainable over time. So pulling this logic out into its own separate file, a service in the case of Angular, solves both of these problems. So what do Angular services actually look like anyway, and how do they work? Well, to answer these questions, here's what we're going to do. We're going to create a listings service that abstracts away all the communications with the various listings routes that we created on our backend. Our components will then be able to use this listings service to do things like load data, create, update, and delete listings, and so on. Basically all the things that we created routes for on our server. We'll see exactly how all this works very shortly. So first of all, to generate a new service in our application, we can do the same sort of thing that we did to generate all the components in our application. That is, we can run the Angular generate script by saying ng generate, and then we're going to say service instead of component, and we're going to call this service listings. And then we're going to hit enter, and that will create a new service in our project called listings, which will only include two files, one being the actual logic of our service, and the other one being a test file. Now, if we open up the listings.service.ts file here, we'll see that it's fairly empty. The first thing to note here is that instead of this decorator at the top of our listings service saying @component, as it did in all of our component files, it says @injectable. And what this means is that it can be injected into any of our components in the components constructor method, just like we saw with things like Angular's activated route or router. And we'll see more on that in a second. For now, just for demonstration purposes, what we're going to do is create a getListings method on our listings service that returns some fake listings, and then we're going to rewrite our listings page to use this service. And this will allow us to see more or less what it looks like to use a service from inside a component. So we're going to start off by importing our fake listings and the listing type into our listings service. So we're going to say import fake listings from fake data, and then import listing from types. And then we're going to add a method to our listings service called getListings, which will simply return the fake listings. So we'll say getListings, and that's going to return an array of listings. And then we're just going to say return fake listings from inside of there. And now that we've done that, we're going to head over to our listings page component and use our listings service to get our fake listings instead of just importing them straight into our component. Here's what that'll look like. First, we're going to import our newly created listings service into our file, and we can also delete these fake listings here since we won't be needing that anymore. And we're just going to say import listings service from /listings.service. And then, in order to use this service from our component, we're going to inject it via the component's constructor, just like we've seen with a few of the other tools we've used. So inside the constructor, we're going to say private listings service. And finally, instead of directly assigning the fake listings to our listings, we're going to use the getListings method that we define on our listings service. So we're going to say this.listingsservice.getListings like that. And that should be about it. If we run our front end, and we're going to just have to fix a type error that happened from when we changed our types earlier. So to do that, we're just going to open up our listing data form component. And then down here, we just have to add views 0. And now our app will run successfully. So now if we open up a browser and take a look at our app, we should see that it still works like before, but now we're using an Angular service to have this fake data instead of just hard coding it directly into our component file. Now that we've learned about services in Angular and created our own service that our front end can use to interact with the server, it's time to take a look at the tools we'll be using to actually do that communication. In order to make network requests in Angular, there are two main tools we need to use. And these are called RxJS and HTTPClient. RxJS is a library that makes working with asynchronous and event-based code a lot easier, and HTTPClient is an Angular module that we can use to actually make the requests to the server. The best way to go further in our understanding here is really just going to be to see both of these tools in action, so let's do that. The first thing we're going to have to do here is open up our app module file and add HTTPClient to it. This will make it so that our Angular components and services are able to inject HTTPClient as a dependency. So up at the top of our file, we're going to import something called HTTPClient module. So we'll say import HTTPClient module. And do make sure that in HTTP, only the H is capitalized. I make that mistake all the time. So we're going to say import HTTPClient module from @angular/common/HTTP. And then the next thing we need to do is just add that HTTPClient module to our apps list of imports like this, HTTPClient module. And now that we've actually done that, we can head over to our listings service and use HTTPClient and RxJS to actually load data from our server. So here's what that's actually going to look like. The way we have it right now, our listing service's getListings method is actually just synchronously returning an array of listings. However, now that we want to load these listings from a server, this is going to be an asynchronous operation, and therefore we have to write this method a little differently. First of all, instead of returning an array of listings directly, this method is going to return something called an observable. And this observable thing is a generic type, and in this case, we're just going to say observable listing array. So this observable thing is how Angular actually incorporates asynchronous logic into its apps. An observable is basically just some task that our app is executing, in this case loading data from a server, that our components can subscribe to. And we'll see exactly how this subscription stuff works in a minute. For now, we want to import this observable type from RxJS by saying import observable from RxJS. And then we're going to import the HTTP client as well by saying import HTTP client from @angular/common/HTTP. And we're also going to delete our fake listings import since we won't be needing that anymore. And the next thing we're going to do now is we're going to provide the HTTP client in the services constructor like this. We're going to say private HTTP client. And now we come to the part that you've been waiting for. The way we actually make a request to our server is by saying return this.http.get with the generic listing type here, and then the URL that we want to send the GET request to. In our case, that's going to be API/listings. And the reason that we're returning this is that the http.get function is an observable, and we want our components to be able to subscribe to it. So now that we've got this method, let's head over to our listings page and see exactly how this subscribing works. In reality, it's actually pretty simple. What we were doing before was just saying this.listings equals listingservice.getListings. But now that this getListings method is returning an observable instead of just an array, what we say instead is just this.listingservice.getListings, and then on the end of this we say .subscribe, and we'll get a callback function that'll get called whenever this getListings observable produces an event. So here's what our callback will look like. It'll say listings, this.listings equals listings. So basically what's going to happen is when our getListings call returns some data, it's going to call this callback with the listings that it got from the server, and we're going to set the listings member variable on our listings page so that those listings will be displayed. So we've got our front end set up to make requests to our backend. However, if we were to try and make an actual request to our server now, we'd end up getting something called a CORS error telling us that the backend has blocked our request. CORS errors are security-related errors that are very common in local development environments, and they happen when, in our case, we try to make a request from one origin to another. In order to get around this for local development purposes, we need to set up something called a proxy. And to do that, there are a few things we need to add to our project. The first thing we need to do is, in the root of our app directory, we need to create a new file, and we're going to call that file proxy.config.json. And this will contain some configuration info that our app can use to set up a proxy for our requests. Here's what that'll look like. We're going to have a JSON object in here, and we're going to say /API/star. And you may notice that this key here is the prefix that we gave to all of our server routes. This is why we started all those paths with /API. It makes it easy for our front end to proxy our requests to the back end because it can just look at the beginning of the path we're making a request to, and if it starts with /API, it proxies our request to wherever our server is running. So inside this object here, we're just going to add a few keys. I'm not going to go into any detail here on these. It's just sort of the setup that we have to have. We're going to say target and the path of our server. In this case, it's localhost 8000. And we're going to say secure false, log level, debug, and change origin true. So now that we've got that set up, we should be able to run our app now, and our requests should work like we want them to. First, let's make sure our backend is running, since otherwise you'll definitely get errors. And now to run our front end, And now to run our front end, we actually have to run our app with a slightly different command. Instead of just saying ng-serve, we have to actually tell our app where to find our proxy configuration that we just defined. And that'll look like this. We just have to add a flag that says proxy config, and then the path to our proxy config file, which is just proxy.config.json, and hit enter. And now, if we open up our listings page, we should see our listings displayed after a second or two, and these listings are from our local database returned to our front end by the listings endpoint on our server. And this is really exciting because for the first time in this course, our app is now officially a full stack application. That is, it's got a front end, a server, and a database, all communicating with each other to provide the user with a web page. Now, obviously, we still have to convert all of our other pages over to use the server as well, but this is a great first step. So before we move on, there's one little change I'd like to make in order to make things easier for us. This new command that we're running our front end with is a bit long, and I definitely don't expect you to remember it. So what we can do here instead is create a shortcut script for it in our package.json file, which will look like this. Let's open up our package.json file. And then down here in the scripts directory, we're going to find the start script, which is just a shortcut for ng-serve. And we're going to change that to ng-serve proxy config proxy.config.json. And now, instead of typing that whole command out like this, all we have to do is type npm run start, or we can just type npm start, that works too. And if we take a look at our listings page again, we see that our app is successfully loading data from our Happi server. Okay, so far our app is loading our listings for the listings page from our backend, so over the course of the next few videos, we're going to be changing over the rest of the pages in our app to do the same thing. So what we're going to do is we're going to start off with the listing detail page and contact page, which will behave fairly similarly. Basically, we're going to have our listing detail page load the data for an individual listing from the getListing route that we defined on our server, and we're also going to have it send a request to the addViewToListing route that we defined to increment the number of views that a listing has. So here's what all of that's going to look like. We're going to open up our listings service if you don't already have it open. And the first thing we're going to do is, since adding views to a listing is going to be a post request, we're going to have to add some headers to the request we're sending. And this isn't strictly necessary for the adding views request per se, but for the rest of the post requests where we send an actual request body, we'll be needing this. So anyway, to add headers to our post requests, we're going to need to import something called HTTP headers, which we do from the same place as HTTPClient. So we're going to say import HTTP headers. And then down here, outside of our listing service, we're going to define something called HTTP options. And then we're going to say equals object. And this object is going to have a key called headers, which is going to be new HTTP headers. And we're going to pass the content type header, whose value will be application/JSON. And basically what this does is it just tells our server that the request body of our post request is a JSON object. And now that we have that, let's define two more methods on our listing service, one for each of the requests that we want to make. We're going to start off with the method for getting individual listing data, which will look like this. We're going to say get listing by ID, and the ID is going to be a string, and the type that it's going to return is going to be an observable that calls its callbacks with a listing object. And then we're going to say return this.http.get, the type listing, and the route that we want to send this GET request to is going to be /API/listings, and we're going to insert the ID into there. So that's simple enough. Now let's do the method for adding views to listings, which is going to look something like this. We're going to say add view to listing, and then the ID of the listing that we want to add that to. And this is going to return an observable listing as well. And for this one, we're going to say return this.http.get dot post, since this is a post request instead of a get request, post listing, and then the route that we want to send this to is /API /listings /ID /add-view. And then we're going to pass an empty object for the body of the post request. And for the third argument, we're going to pass this HTTP options object that we created. So now that we've defined these two methods, let's head over to our listing detail page component and use these methods we just defined. So we're going to open the listing detail page .ts file up, and we're going to import our listings service and delete our fake listings. So we'll say import listings service from /listings service. And then what we're going to do, since our data isn't being set on our component instantaneously anymore, is we're going to define a new member variable here called isLoading that we'll be using to display a loading message on our page. So this will just be a Boolean, and its starting value will be true. We'll see how this is used in a second. So the next thing we're going to do now is we're going to inject our listings service through the constructor. So we'll say private listings service, and then down here in ng-on-init, instead of just saying this.listing equals fake listings.find, we're going to use the methods that we defined on our listing service. So we're going to say this.listingService.getListingById. And for that, we're going to pass this ID that we're getting out of the route parameter. And then we're going to say .subscribe. And our callback here is going to get called with a listing. And when that happens, we want to say this.listing equals listing. And we want to say this.isLoading, set that equal to false. So that's how we load our listing. The second thing we want to do in ng-on-init is add a view to our listing, which we can do by saying this.listingService.add view to listing ID. And then we're going to add .subscribe, because we do need to add .subscribe in order for this add view to listing thing to actually execute. And when that finishes, we're just going to say console log views updated. And that should be all we need. So that's pretty much it for our TypeScript component. The next thing we're going to do is open up our listing detail page HTML. And remember that when we built this page originally, we didn't put anywhere on our page where we displayed the actual number of views that a given listing had. So let's add a component for doing that. Basically, all this is going to look like is inside our content box here, we're just going to have a paragraph tag that says something like this listing has been viewed, listing.views times. And then what we're going to do is we're going to use this new isLoading member variable that we added to either display the page itself or a loading message. So here's what that'll look like. We're going to add a structural directive to this outer div here. We're going to say ngIf, and we only want the actual page to display if the isLoading member variable is false. Otherwise, what we can do is we're going to do div class equals content box, and then we're going to say ngIf, and we're going to say if isLoading is true, what we're going to do is just display a little heading that says loading ... So now if we go back to our application and click on one of these here, we'll see that it says this listing has been viewed 0 times. And then if we go back and forth with these again, we'll see that it increments the number of times that a listing has been upvoted. So that should be it for our listing detail page. What we're going to do now is do something very similar with our contact page. So let's open up our contact page here, and we're going to go into component.ts. And what we're going to do is inside ng-on-init, instead of using fake listings here, we're going to use our listings service. And first we need to import our listings service. So we're going to say import listings service from ... listings.service. And then we're going to add that to our components constructor. So private listings service, listings service. And we're going to use that inside our ng-on-init method by saying this dot listing service dot get listing by ID, ID. And then we're going to say dot subscribe listing. And when the listing is loaded, we're going to say this dot listing equals listing. And that's also where we're going to set the message here. Hi, I'm interested in your, and then the listing name. So now if we go back and take a look at our app and click on Contact Seller, we should see that it loads the correct data. The next page that we're going to connect to our server is the My Listingspage. Now, there are two pieces of functionality on this page that need to make requests. The first is that we actually need to load the user's listings in the first place, and the second is that we need to delete listings whenever the user clicks the delete button on a given listing. So just like with our listing detail page, let's start off by adding the corresponding methods for these two tasks to our listings service. So let's open up our listings service here. And the first method we're going to add is going to be called getListingsForUser. This will load the user's listings for the My Listings page. And this is going to return an observable that calls its callback with a listing array. And for this, we're just going to say return this.http.get, and this is going to return a listing array as well. And the URL we want to send this to is going to be /API/users/12345. We're just going to hard code this user ID right now, but once we add authentication to our app, this will be put in dynamically. And then /listings. So that's our getListingsForUser method. The next method we're going to define is going to be called deleteListing. And it's going to take the ID of the listing we want to delete, which is going to be a string. And it's going to return an observable. But since this endpoint doesn't actually respond with a listing, we're just going to put any for the type of the observable here. And we're just going to say return this.http.delete. And we can put any here as well. Or we can just leave it without anything. And the URL that we're going to send this request to, we're going to use backticks and say /API/listings, and then put the ID into the URL. And now that we've done that, let's head over to our My Listings page and actually use these methods. So here's what that'll look like. Let's open up our My Listings page component. And up at the top here, we're going to import our listing service. Import listing service from /listings.service. And we're going to delete fake my listings here, since we won't need that anymore. And inside the constructor, we're going to inject our listings service like this, private listings service, listings service. And then in our ng-on-init method, instead of just saying this.listings equals fake my listings, what we're going to do is subscribe to our observable, like we've done in our other components. So we're going to say this.listingsService.getListingsForUser. And then we're going to say .subscribe listings. And when this completes, we're going to set this.listings equal to the listings we get back from the server. So that's how we load the user's listings for the page. The next thing we need to do is actually delete a corresponding listing when the user clicks the delete button. So here's what that'll look like. We're going to delete this alert here. And we're going to say this.listingsService.deleteListing, listing ID. This will be getting passed to us from the button that we click on. And then we're going to say .subscribe. And then when this completes, we're going to use a little trick to prevent us from having to reload the listings again. What we're going to do is just say this.listings equals this.listings.filter, and then filter out the listing that we just deleted on the server. We're going to say listing, and we're going to say we only want the listings where the listing ID is not equal to the listing ID that we just deleted up here. And that should be all we need to do. Now, if we test this out in the browser, we should see that it's loading our listings from our MySQL database. And furthermore, if we click on the delete button, it deletes the listing. And just to make sure, if we refresh, sure enough, that listing is gone. So that's exactly what we wanted at this point. However, note that if you delete all of your listings, there's not really a good way to get them back yet. For that, we'll need to hook up our new listing page to the server. So here's what adding server requests to our new listing page will look like. Like we've done with our other pages, we're going to start off by adding a new method to our listings service. So let's go back to our listings service, and the method we're going to add is going to be called createListing, and it's going to take 3 arguments: the name of the new listing, the description of the new listing, which is going to be a string as well, and the price of the new listing, which will be a number. And this method is going to return an observable that calls its callback with a listing type. And then inside this method, we just have to say return this.http.post. Remember that we have to use a post request since we want to send along this extra information when we create our new listing. And this post request is going to respond with a listing. And the URL we want to send this request to is going to be /API/listings. And for the response body, we're going to pass along our name, description, and price arguments inside a JavaScript object. And then we just need to pass along the HTTP options that we defined up at the top, just like we did when we added views to listings. So that's all we need to do for our listing service. Now let's open up our new listing page. And just like with our other pages, we're going to start off by importing our listing service. So import listing service from /listings.service. And we're going to inject that service into our constructor like this: private listing service. Listing service. And the next thing we're going to do is we're going to rewrite our onSubmit method here. So instead of just displaying an alert, we're going to say this.listingService.createListing. And then for the name, description, and price, we're going to have to get those through the arguments of this onSubmit method. I'll show you how to do that in just a second. For now, to do that, we're just going to say name, description, and price, like that. And then we're going to pass those as arguments to our createListing method, just like this: name, description, and price. And then we're going to say .subscribe. And when this finishes, we're going to put this.router.navigateByURL statement inside the callback here, so that when this operation completes, it'll navigate us back to our My Listings page. So in order to actually get this data, remember that in our listing data form component, we called this.onSubmit.emit thing with the data that the user filled out in the inputs. And the way that we actually access this data from inside our new listing page up here on our onSubmit method is by opening up our new listing page's HTML file. And here, where we're tapping into the onSubmit output of our listing data form, all we have to do is add this little $event thing to the parentheses of the onSubmit method. What this will do is it'll pass whatever data we called the emit function with to this onSubmit method. So we're going to save that now. And now we should be able to head back to our app and create new listings by filling out stuff like this. We'll just fill this out with some random data here. And click Create Listing. And we should see the listing that we just created show up on our My Listings page. Okay, so we've come to the last page that we need to hook up to our server, and that is the Edit Listing page. So here's what connecting it to the server is going to look like. As usual, we're going to start off by creating a new method in our listing service. We're going to call this one Edit Listing. And we're going to pass the ID of the listing that we want to change, as well as the updated name, description, and price of the listing that we filled out in the inputs. And this will return an observable that calls its callback with a listing. And then inside this method, we're going to say return this.http.post, and this request will respond with a listing. And for the URL that we want to send it to, that's going to be /API/listings/ID. And for the request body, we're going to pass along our name, description, and price, as well as the HTTP options. And now that we have that, let's head over to our edit listing page. And we're going to import our listings service up at the top. So import listings service from /listings.service. And then we're going to inject it in our constructor. So private listings service, listings service. And then inside our ng-on-init method, instead of saying this.listing equals fake mylistings.find, we're going to delete that and say this.listingservice.getListingById. ID. So remember that we're loading the corresponding listing here. That's also why this page didn't get populated when we first visited it. And then we're going to say .subscribe. And when we get the listing back in the response, we're going to say this.listing equals listing. And then inside our onSubmit method is where we're going to actually send our edit listing request. So instead of just saying alert up here, we're going to say this.listingservice.editListing. And for the listing ID, we're going to say this.listing.id. And we're also going to pass the name, description, and price, which we have to get out of the arguments here, just like we did in our new listing page. So we're going to say name, description, and price up here as well. And then we're going to subscribe. So .subscribe. And when this completes, we're going to put this.router.navigateByURL thing inside the callback. And the last thing we have to do is, just like we did with our new listing page component, where we added this event thing, we're going to add that to our edit listing pages HTML. So let's open that file up. And we're going to add $event to the parentheses of our onSubmit method here. And we're also going to make a change here so that it only displays this page after the data is actually loaded. So what we can do is we're going to add an ngIf structural directive here. And we're going to say if we have a listing, display this. Otherwise, we're going to say div class equals content box for styling, and then ngIf. And if there isn't a listing, what we want to do is we want to simply display an h3 tag that says loading, ... and that'll prevent this page from displaying before we've loaded our listing. So now if we go over to our edit listing page, we see that it's successfully populating all of the existing values for our listing, and that we should be able to make changes to it. And click on the Save Changes button. And we see that those changes are now reflected in the data that we're loading from the server. Okay, at this point we've got a fully functional full-stack app. We built out an entire front end and back end, and now they're communicating with each other just the way they should be. However, before we release our application into production, there's one thing that's a very important part of most applications, and that's authentication. Now, at its most basic, authentication simply means that our application allows users to create accounts and then log in and log out. And it also means that our application keeps track of what belongs to who in our application and prevents users from doing things that they shouldn't be able to do. For example, we don't want users to be able to edit or delete each other's listings, of course. In this section, we're going to see how to add basic authentication functionality to our app. Now, obviously, one possibility of adding authentication to our app would be to build out the entire auth flow from scratch. However, authentication can be a very complex and time consuming thing to implement, and at the end of the day, the humble fact is that most of us just don't have the expertise to implement a secure authentication flow. So, what we can do instead is use what's called an auth provider. Basically, an auth provider is a third party that takes care of all the complexities of authentication for us. In this course, the auth provider we're going to be using is called Firebase Auth, which is a tool provided by Google largely for free. So as you'll see in coming videos, Firebase Auth makes the user authentication process incredibly easy. We don't have to worry about all these things like encryption, salt, etc. All we have to do is call a single function to do things like sign in and sign out. And we'll go into more detail shortly about how exactly this all works, as well as set up our own Firebase project in the Firebase console, which is what this is. So Firebase Auth gives us a pretty wide range of possibilities for how we want to allow our users to authenticate. And this includes standard email password authentication, phone authentication, and a number of OAuth providers, as well as things like email link authentication, which allows users to simply sign in by sending a clickable link to their email address. And adding all of these things to our application takes very little groundwork, as you'll see. In this course, we're just going to be adding some standard OAuth functionality that will allow users to log in with Google, and this will make it very simple and straightforward for us to allow users to log in and out. So now that we know what Firebase Auth is and why we're going to use it, the first thing we have to do in order to add authentication to our application is create a Firebase account. And then we'll need to create a project for our application in Firebase. So we're going to take a look at how to do those things, and as we walk through all of this, keep in mind that the Firebase console might change a bit over time, as most websites do. So if you see something that's not quite the same as what I have, don't worry about it too much. The basic flow and concepts that we'll see here should stay pretty much the same. So to create an account, you're going to want to open up a browser and go to firebase.google.com. And once you're there, you're going to want to click on this Get Started button. And at this point, if you're not already signed into a Google account, it's going to ask you to sign into one of those. So anyway, once you've done that, Firebase should take you to the Firebase console, which looks pretty similar to the page we just came from, except that now, instead of a Get Started button, we see a Create Project button. Projects are basically just how Firebase organizes your different applications. So let's click on Create a Project. And for our project name, we can really use whatever we want. This is just an internal string that we use to identify our projects, so it's nothing our users will ever see, and you can change it whenever you want to. So for now, we're just going to say buy and sell. And you'll see that as you type your project name, Firebase will have this little box underneath it. And this is your project's project ID. So once you've decided on a project name and project ID, you're going to click this little checkbox here to say that you've already read all the Firebase terms thoroughly. And then click Continue. And this will bring us to a page that asks if you want to enable Google Analytics for the project. I'm just going to leave this turned on for this course, and click Continue. And finally, it'll take you to a page for configuring Google Analytics. This isn't overly relevant to the course, so I'm just going to leave the defaults, click Accept for both of these, and click on Create Project. And once you do that, this little spinner thing will go for a while Firebase is setting up your new app. And once it says your project is ready, let's click on Continue, and this will bring you to the project console for your app. Now, there's a lot of stuff to look at here, but over on the left, we see that we have this sidebar with a few tabs. For example, we have this Develop tab, which allows us to set up things like authentication, which is what we're going to be using for this course. So let's actually click on this authentication button here. And the last piece of setup we're going to need to do in this console is we're going to need to create a sign-in method for our application. A sign-in method is basically just a way that we're going to allow our users to sign in. For example, with their email address and password, with their Google account, with their Facebook account, and so on. And for this application, we're just going to have users sign in with their Gmail account. So let's click on Sign-in Method here. And we're going to find Google in the providers list and click on Edit. And then we're just going to click on Enable. And for the project support email, we're just going to select our email address here. And then we just have to click Save, and that's all we need to do for now in the console. Now that we've created the Firebase project for our app, which will allow us to add authentication functionality, we need to actually hook our Angular app up to this Firebase project we created. In the Firebase console, we need to go back to our project's homepage, which you can get to by clicking on this project overview in the top left. And then in the middle of the screen here, we're going to click on this web icon. This will ask us to name this specific app. And by the way, Firebase uses the word app to refer to specific platforms that a given project runs on. So in our case, we're going to call ours Angular Frontend. And just leave this checkbox unchecked. And then click on Register App. And once we've done that, Firebase will spit out all this code for us to copy and paste into our project, which contains things like the API key, as well as the behind-the-scenes URLs. And note that all this information is actually safe to share. In other words, none of these things is a secret key that the client can steal and use to exploit our application. Now, since the application we're using is an Angular app, we're actually not going to copy and paste all this code as is. What we're going to do instead is leave this window up and head over to our front-end project code. And what we need to do is we need to install a few npm packages into our front end. So we're going to say npm install at Angular/Fire. This is a package that helps us add Firebase to Angular. And then we're going to install the Firebase package itself and hit enter. And once we've done that, here's how we actually use these packages. Let's open up our app.module file. And we're going to add a few things here. The first thing we need to do is import a few modules up at the top. So we're going to say import Angular Fire module from at Angular/Fire. And we're going to say import Angular. And we're going to say import Angular Fire Auth module from at Angular/Fire/Auth. And then we need to add these two modules to our app's imports. So we need to say Angular Fire module, and this is going to be a little different from our other imports here. We have to actually say Angular Fire module .initialize app. And then we're going to say environment.firebase, and we'll see what this environment.firebase thing is in a second. And after that, we're just going to add Angular Fire Auth module. And that should be all we need. Basically, what these modules do is when we run our app, they allow our app to communicate with the Firebase project we created in the Firebase console. So now all we have left to do is go back to the browser and copy this Firebase config JSON thing that Firebase spat out for us. And then we're going to go back to our front-end app, and we're going to look for a folder called environments right here. And inside that folder, there will be a file called environments.ts. So let's click on that. And then inside this environment object, right underneath the production key, we're going to define another key called Firebase. And we're going to paste what we just copied from the Firebase console into here. And this, as you may have guessed, is what the environment.firebase thing was in our app.module file. So now we just need to import environment from the file we were just in. So we can say import environment from /environments/environment. Now that should be all we need to do to add Firebase to our front end. The next thing we're going to do is add Firebase to our back end. Now on our front end, we're going to be using Firebase Auth to allow users to log in and log out, and we'll see how that's done shortly, but it's only half of the equation. What we need to do also is use Firebase Auth on our backend to do things like verify users and make sure that users are only allowed to edit and delete their own listings. So adding Firebase to our backend is pretty similar to what we just did with our front end, except the names of the packages are going to be slightly different. And actually, the only package we'll need to install here is called Firebase Admin, which we can install by saying npm install Firebase Admin and hitting enter. And once we've done that, we'll need to open up our server.js file. And up at the top of the file, we need to import this Firebase admin thing like this. We're going to say import star as admin from Firebase admin. And then at the very top of our file, up above where we even define our server here, we're just going to say admin.initialize app. Now, before this will actually work, what we need to do is give our server the right credentials. Our server will be doing some pretty sensitive things like verifying users' auth tokens, so we need to generate a secret key in Firebase and give that to our server to allow it to do that kind of thing. So here's how we do that. We're going to need to go back to our Firebase console, and if you still have this page up, you can just click on Continue to Console. And then we're going to open up our project settings by clicking on this gear icon here and clicking Project Settings. And then we're going to go over to this tab here that says Service Accounts and click on that. And then down here near the bottom of the page, we're going to click this button that says Generate New Private Key. And then we're going to click Generate Key. And this will download a JSON file for us containing some very sensitive information, so be careful with it. Now, what we're going to do is we're going to move this file into our project. So what I'm going to do here is open up a terminal and say mv:/downloads/ and then whatever the name of your project is. And you should be able to hit tab here and it'll autofill it for you. And then I'm going to move that to this current project and just copy the name here, just like that. And then if we take a look at our file tree here, we should see that that file is now inside the root directory of our project. And then just for ease of use here, what we're going to do is we're going to rename this to something like credentials.json instead of that big long name. So what we can do now is back inside our server file, we're going to import the data from that file we just moved into our directory. And we're going to say import credentials from ... credentials.json. And then what we need to do is we need to pass these credentials to our initialize app function. So that'll look something like this. We're going to say credential admin.credential.cert and pass our credentials JSON object to that. And that's all we really need to do to set up Firebase on our backend. Now, one thing to remember is that this credentials.json file does contain secret keys, so make sure that you don't commit it as is to GitHub or anywhere else that people might see it. So if you have a gitignore file, for example, you might want to add the name of that file to it. So credentials.json. And also keep in mind that for these very security reasons, the exercise files for this and all following videos won't include this credentials.json file, since it points at my own app. So you'll have to add in your own file if you want to run those. Okay, so now that we've added the basic Firebase auth setup to both our front and back end, the next logical step is to allow our users to log in and log out. And the fact is that while all that setup we just went through was maybe a bit complicated, now that we have it all done, actually performing the authentication is almost laughably easy. In this video, we're going to see how to do that, as well as how to display some message when users aren't logged in. Basically just a screen that says something like, hey, you need to log in first. So the first thing we're going to do is we're going to open up our app component file. This is the component where we'll be letting users log in and out from. And up at the top here, we're going to say import Angular Fire Auth. That's the package that we'll be using to log in with. From @angular/fire/auth. And then we're going to say import auth from Firebase/app. And then what we're going to need to do is we're going to need to start off by adding a constructor method to our app component. And that'll look like this. And then inside that constructor, we're going to inject our Angular Fire Auth package. But instead of saying private for this package, what we're going to do is we're going to say public auth Angular Fire Auth. And you'll see why we're doing public in a second. And what we're going to do now is we're going to define two methods inside of our app component. One for signing users in. This will be triggered when they click the sign in button, which we haven't defined yet, by the way. We'll get to that soon. And this method will look something like this. We're going to say sign in clicked. And you can put void for the type here, since it's not going to return anything. And then we're going to say this.auth.signin with popup. And then inside of there, we're going to say new auth.google auth provider with parentheses after it. So what this is going to do here is it's going to bring up a new tab in our user's browser that'll have them sign in with their Google account. We'll see exactly what that looks like shortly as well. So that's our sign-in method. The next thing we're going to do is define a method for signing out, which will be triggered when the user clicks the sign out button, which we also haven't defined quite yet. So that's going to look like this. We're just going to say sign out clicked. This will be void as well. And we're just going to say this.auth.signout. So signing users in and signing them out when using Google Auth is really just as simple as this. It's a simple function call to sign in and a simple function call to sign out. So that pretty much completes our changes to our app's TypeScript file. The next thing we're going to do is make a few changes to our app components HTML file. Basically what we're going to do here is first we're going to create two different screens that will be displayed depending on whether the user is logged in or not. And second, we're going to add sign in and sign out buttons that are going to be linked to the methods we just created. And that'll look like this. We're going to start off by having this div with our router outlet and navbar only be displayed if the user is logged in. So what we're going to do is we're going to use an ngIf structural directive here, and we're going to say auth.user pipe async. And all this async thing here means is that auth.user is asynchronous and we want to listen for changes to it. So once we've done that, the next thing we're going to do is underneath this content wrap div, we're going to add a sign out button, since this whole div will be shown when the user is signed in. So we're going to say button, and then for the button's click event, we're going to say sign out clicked, and then sign out. And the next thing we're going to do now is define the elements that should be displayed if the user is not currently logged in. So here's what that's going to look like. We're going to say div id equals max width column, and we're going to say star ngIf, and we're going to do the opposite of the structural directive that we had up here. So we're going to say not, and then we need to use parentheses here to wrap what we're going to type. So not auth.user pipe async, and that'll just display whatever's inside this div only if there isn't an auth user. And inside this div, when the user's not authed, we want to just display a heading that says something like you need to sign in first. And underneath that, we'll have the sign in button, which will look like this. For the click event, we're going to call our sign in clicked. And we'll say sign in with Google for the button's text. And now we can test this whole flow out by opening up our app. You should make sure that your front end and back end are both running before you do this. And if we go over and take a look at our app, we see that we have this sign in with Google button now that we can click on. And this will open up a new tab that allows us to pick the Google account we want to sign in with. So I'm going to log in with this email address here. And that'll send us back to our front end. And lo and behold, we're now logged in and we can see the rest of the app. And we can also sign out again if we want to by clicking the sign out button we created. And we'll just see the sign in screen again. So now that we've allowed users to sign in and out, it's time to start incorporating Firebase Auth into some of the other parts of our app. Recall that earlier in the course, there were several places in both our front end and back end where we sort of faked a user by hard-coding a user ID. The getListingsForUser method in our listings service was a good example of this, where we simply hard-coded 1, 2, 3, 4, 5 for the requests that our front end made to our back end. But now that our users are actually logged in, the currently logged in user will have a unique user ID that Firebase Auth automatically assigns to them. So let's take a look at how we can use this ID to make our app actually load the correct listings for a user. Now, this will involve making changes to both the front end and back end, but we're going to start with the front end here. So inside our listings.service file, let's make a few changes. The first thing we're going to do is up at the top, we're going to say import Angular FireAuth from @Angular/fire/auth. And then what we're going to do is, just like we defined this HTTP options thing that we passed along with some of our requests, we're going to define a function called HTTP options with auth token. And what this will do is it's going to take the user's auth token and pass that along with the request's headers. So what we're going to do is we're just going to copy this headers thing here and put that inside of here. And then underneath content type, we're going to add auth token and pass along the token that we're getting from the argument. So now that we have that, the next thing we're going to do is we're going to provide the Angular FireAuth module to our listings service so that it can use it. So underneath our private HTTP here, we're going to say private auth Angular fire auth. And next, we're going to modify our getListingsForUser method so that it actually uses the currently logged in user's ID and auth token. Now, I'm just going to code all of this out first, and then I'll explain it. It's going to get a little lengthy, but don't worry too much about it. What we're going to do is we're going to say return new observable. We're going to create a new observable here, listing array, and then we're going to pass a callback to this new observable here. That'll say observer. And what we're going to do is we're going to say this.auth.user.subscribe. And when we get a new user, we're going to check to see if the user exists. And if they do, we're going to say user.getIDToken, parentheses.then. And when we get their ID token back, we're going to check to see if the user and token exist. And if they do, then what we're going to do is we're going to say this.http.get. And instead of hardcoding 1, 2, 3, 4, 5 here, we're going to change this to backticks and insert the user's unique ID here. And we do that by saying user.uid. And then we're going to actually subscribe to this inside of here. So we're going to say .subscribe. And for the callback, we're going to say listings. And we're going to say observer.next. And pass along those listings to whoever's listening to this getListingsForUser method. And one more thing we need to do here is, as the second argument here, we're going to pass along our HTTP options with auth token and pass the token object that we got for the user. And one more thing we're going to do here is just add an else clause to this if statement. So if either the user or token don't exist, we're just going to call observer.next with an empty array, which will pass just an empty array to whoever subscribes to this method. Okay, so what's all going on here exactly? Well, instead of just returning this http.get observable that our components can subscribe to, what we're doing is we're creating our own observable whose behavior is a little more complex. Basically, what we have here is a series of nested observables where we start off by getting the current user, then getting their auth token, and then we make the http.get request with those 2 extra parameters. And then, if everything went well, what we do is we return the listings that we loaded from the backend. Otherwise, we simply return an empty array. So that should be all the changes we need to make to our front end for now. Let's move on to our backend. This is going to involve making some changes to our getUserListings route, so let's open that up. And then up at the top, we're going to say import star as admin from Firebase admin. And this Firebase admin package is the package that will allow us to do things like verify the user's auth token, which we can do like this. We're going to start off inside our route handler by getting the auth token header that we're sending from the front end. So up here, we're going to say const token equals request.headers.auth token. And then we're going to get the corresponding user from the auth token and make sure that that user matches the user whose data is being requested. If it doesn't, then we'll throw a boom error saying that whoever is sending the request isn't authorized. So here's what that'll look like. We're going to say const user equals await admin.auth parentheses .verify ID token. And we're going to verify the token that we got from the request header. And then what we're going to do is underneath this user ID thing here, we're going to say if the user that we got from Firebase auth, if their user ID is not equal to the user ID that's being requested, then what we're going to do is we're going to say throw boom.unauthorized with a message saying users can only access their own listings. And I'm just realizing now that this should be request.headers.auth token instead of request.header, so make sure to change that. And that should be about all we need for now. If we test our application now, we might need to sign in again first if you signed out. At this point, we should be able to go over to our My Listings page, and at this point, we'll see nothing. But that's just because we're now logged in with our Gmail account, and so the user ID that we're now sending with our requests is not the 12345 ID that we created a lot of our listings with. For that, we'll need to make the same kind of changes that we made in this video to the create listing flow. So let's take a look at how to incorporate authentication into our new listings page and the corresponding server endpoint. Now, just like with getting a user's listings, we're going to start off by modifying the create listing method in the listings service. This will probably look very familiar. We're going to say something like this. We're going to say return new observable listing, and then we're going to say observer, and we're going to say this.auth.user.subscribe, and get the currently authenticated user. And then we're going to get the user's auth token, so we're going to say user and user.getID token. And then we're going to say .then, since this is a promise, and we're going to say token. And once we have the token, we're going to copy and paste the original request like this, without the return statement. So we're going to say this.http.postlisting. We're going to send it to the API/listings endpoint with the payload of the name, description, and price that we want to create a new listing with. And then instead of HTTP options, we're going to have to change this to HTTP options with auth token and pass the auth token that we got. And then we're going to say .subscribe. And whenever something happens, we're just going to say observer.next. Just like that. So that's the front end. For the back end, we're going to make a few simple changes to our create listing route. So let's open that up here. Open up create new listing.js. And we're going to start off by importing Firebase admin. So import star as admin from Firebase admin. And then just like with the route that we saw previously, we're going to get the auth token from the request headers and verify it, which will look like this. We're going to say const token equals request.headers.auth token. And then we're going to get the actual user by saying const user equals await admin.auth.verify ID token. And then instead of saying const user ID equals 12345 and just hard coding that here, we're going to say const user ID equals user.user ID. And note that at this point, we might want to check to see if this user actually exists so that we're not just creating a new listing without a given user. But for now, I'm just going to skip over that since you know how to add that already. And those should be all the changes we need. The rest will be reflected down here. The new user ID that we're no longer hard coding will be inserted into our SQL query, and that should make it work exactly the way we want it to. So now if we save this file and go back to our My Listings page, we should be able to click on Create New Listing and fill something out like this. And click on Create Listing. And we should see that show up inside our My Listings list here. Now that we've done the Create Listing flow, our next step is to incorporate user authentication into the Edit Listing flow. This will actually be incredibly similar to what we just saw. What we're going to do is head over to our front end and scroll down to the Edit Listing method. And inside there, we're going to say return new observable listing. And then we're going to say observer, and this is going to be a callback. And inside there, we're going to say this.auth.user.subscribe. And we're going to use that user object to get the user's ID token. So we're going to say user and user.getID token. Then. And once we have the token, we're going to copy and paste the original request here into this callback. And we're going to change this to HTTP options with auth token. And then we're going to say .subscribe and just call observer. Oops, and actually this should be observer up here. So we're going to say observer.next. So that's the only change we really have to make on our front end. On our back end, we're going to make some changes to our update listing route. So let's open that up. And up at the top, just like we've seen in our other routes, we're going to import star as admin from Firebase admin. And then down here underneath where we get the name, description, and price from the payload, we're going to say const token equals request.headers.auth token. And then we're going to say const user equals await admin.auth.verify ID token. And we're going to verify that token that we're getting from the headers. And then instead of saying const user ID equals 12345 and hard coding it here, we're going to say const user ID equals user.user_ID. And that should be all we need to do now. So if we take a look at our application again, we should be able to edit it and click Save Changes. And we should see those changes updated from our database. All right, we've done the My Listings page, the Create Listings page, and the Edit Listings page. So the last step in this section is going to be to add user authentication to the delete listing flow. So here's what that's going to look like. Inside our listing services delete listing method, what we're going to do is we're going to say return new observable. And this is going to be observable any instead of observable listing, since the delete listing endpoint doesn't actually return a listing. And we're going to say observer. And then this.auth.user.subscribe. Pretty much the same as what we've seen anywhere else. And then user and user.getID token. Then token. And we're going to copy and paste this request and say this.http.delete. And we're going to pass the HTTP options with auth header. And we're going to pass the HTTP options with auth token to this delete request. Just like that. And then we're just going to say subscribe. And when that updates, we're going to call observer.next. So nothing too complicated there, pretty much what we've seen before. Now let's move over to the back end, and we're basically going to do what we've done with the rest of our routes. So let's open up our delete listing route. And then underneath here, we're going to say const token equals request.headers.auth token. And then const user equals await admin.auth.verify ID token. And of course, we need to actually import auth up at the top. And of course, we need to actually import admin up at the top. So we're going to say import star as admin from Firebase admin. And then we're just going to say const user ID equals user.userID. And what we're going to do is we're going to insert this user ID into our MySQL query to make sure that the listing will only get deleted if the correct user is actually requesting it. So we're just going to add and user ID equals question mark. And then we're going to add user ID to this array argument here. And now we should be able to go back to our app and delete our listings, and it'll work fine. If we refresh the page, it'll still be gone. And that's about it. So keep in mind, too, that we didn't add all of this auth stuff to every single route on our server. And while you may or may not want to eventually do that at some point, the routes that we've done are the critical routes where we need to prevent users from doing things that they shouldn't be able to do, such as delete each other's listings. For things like fetching a list of all the users on the site, the need isn't quite as strong to make sure that users are authenticated. Okay, at this point in the course, we've got our entire full-stack application set up. We've got the Angular front end, we have the Happi.js server, we have a MySQL database, and we have Firebase Auth as our auth provider. And all of this is something to be really proud of, since not many web developers know how to do what we just did. Most web developers spend their entire careers working on either the front end or the back end without ever seeing how all the pieces fit together like we've done so far in this course. However, at this point, all of these pieces are still running locally on our own computer, and the only ones that can access them are ourselves. So in this section, we're going to see how we can move our app to the cloud so that it can be accessed by anyone. And to host our app, we're going to be using a platform called Google Cloud. Now, if you've never deployed a full-stack app before, this might seem pretty scary. As developers, we're generally used to just working on the code and letting someone else take care of all the deployment and hosting stuff. And to be honest, it might be a little bit out of your comfort zone at first, but once you've seen how it all works and all the details to be aware of, I guarantee you'll become comfortable with it fairly quickly. Now, before we get into deploying our app, let's first take a look at the basic process we're going to be following. This will help put everything we'll be doing throughout the rest of the course into perspective. Here are the basic steps we're going to be following. The first thing we need to do is install Google Cloud's command line tools. These tools contain scripts that we can run that will quickly and easily deploy our code to Google Cloud. Next, we're going to be setting up a MySQL instance on our Google Cloud. Currently, we've been storing all our data on a local database, but in order to release our app, we'll have to have our database in a more accessible and available location. After that, we're going to move our Happi server to Google Cloud, followed by building our front-end app, having our Happi server serve our front-end's files, and then deploying all of that to Google Cloud. And that should be about it. Now, you may have noticed that we don't really need to do anything with Firebase Auth in this process, and that's because Firebase Auth is already on the cloud. If we really wanted to, we could have run Firebase Auth locally, but that's a slightly involved process, and it's not really that relevant to the course. Anyway, that's just one less thing we have to do in this section. So now that we know a little bit more about how the process of hosting our app is going to work, the first step we're going to take is to install and set up the Google Cloud CLI tools. So the first thing we're going to want to do here is go to the Google Cloud console in your browser. And this is a different thing than the Firebase console that we used earlier when we were adding authentication to our app. You can get there by going to console.cloud.google.com. And when you go there, you might need to set up your account. At the moment, Google Cloud is offering a free trial for new accounts. So I'm going to click on Agree, Agree and Continue. And I'm going to click on Try for Free here. And just walk through the basic setup. And you might need to fill out some of your billing information. However, Google Cloud will not bill you until you turn on automatic billing, so don't worry about that. And once you click Start My Free Trial, it'll bring you here and just click Got It. And now that we've set up our Google Cloud console, let's head back to our terminal and install the command line tools. So here's how we do that. We're going to say curl https://sdk.cloud.google.com and then pipe bash and hit enter. And then it's going to ask you a few questions. I usually just leave the defaults for those. And then we're going to need to run the command exec-l $shell to reload our terminal. And now we should be able to say gcloud init and hit enter. And this will take us through configuring our Google Cloud CLI. So it'll ask us if we want to log in, and we're going to say yes for that and hit enter. And that's going to open up a login window for us here. So just pick the account that you set up your Google Cloud account with. And we're going to click on allow. And now we're going to go back to our terminal, and it's going to ask us which cloud project we want to use. We're going to select our buy and sell project, and this was created when we created our Firebase project in the Firebase console, since those two things are linked on Google. So I'm going to enter 2. Your option might be different. And that should be all we need to do. Just to make sure that Google Cloud is set up with our correct project, we're just going to type in gcloud config get-value project, and that should show the project ID of our buy and sell site that we created. So now that we've got our Google Cloud set up, the next thing we're going to do is move our MySQL database to the cloud. And to do that, we're basically just going to create a new MySQL database on the cloud and walk through the same kind of setup that we did earlier in the course when we created our local database. So let's open up the Google Cloud Console, and the first thing we need to do is make sure that we're on our buy and sell project by clicking on the drop-down menu up here. And once we're there, we're going to open up the menu on the left and scroll down to where it says SQL. And we're going to click on that. And then it'll just ask us for a billing account, and we'll select My Billing Account and click Set Account. And then we're going to click Create Instance, and we're going to select MySQL here. And then we're going to need to fill out a few pieces of data about our new database. For the instance ID, let's put in buy and sell DB. And then for the root password, just put in something you'll remember. And then select whatever region is closest to you, and leave zone on any. And we're going to leave database version on MySQL 5.7 and click Create. And after that, we'll need to wait a few minutes for Google Cloud to set up our database. But once that finishes, we're going to click on the name of this database we just created. And the next thing we're going to do is connect to this new database using the MySQL Workbench program that we used earlier. So let's open that up, and you're going to want to go back to the home page here. And once you're there, we're going to click on this little plus button next to MySQL Connections. And this will bring up a pop-up window that we need to fill out. So for the connection name here, we're going to name this Buy and Sell DB. And now for the host name, we're going to need to go back to our Google Cloud Console and find the public IP address of the database we created. That'll be right here. So we're going to copy that and paste that in the host name box here. And then for username, we're going to leave it on root, and we're going to need to provide the password that we created for this later. And then we're going to leave this last box blank and click OK, and that'll add our connection to the list here. Now, before we can actually connect to our Google Cloud database, we're going to need to tell Google Cloud to allow our computer to connect to it, otherwise it'll block us. So let's go back to the Cloud Console, and over on the left here, we're going to click on Connections. And then we need to scroll down to this Authorized Network section here and add our own computer to it. So we're going to click on Add Network, and then for the name, we're just going to say something like Local Computer. And then for the network, we'll need to find out what our IP address is. And to do this, you can just open up Google and search for what's my IP address. And then we're going to copy that and paste it inside the network box. And then we're going to click Done. And then we need to click Save here. And this might take a little while to complete as well. So now that we've done that, we should be able to connect to our cloud database. So in MySQL Workbench, let's click on the new connection that we created. And that should ask us for our password here. Just input whatever password you assigned there. And now we're connected to our cloud instance of MySQL. So the setup here is going to be almost identical to what we did earlier. We're going to create a new schema called Buy and Sell. So click on this little button up top. And we're going to name it Buy and Sell. And then click Apply. And Apply. And Close. And then we're going to create a listings table to store our listings. Now, instead of doing this all manually, what I'm going to do is simply copy and paste a MySQL query here that'll do all the basic setup for us. And you can find that in the exercise files too. And you can find that in the exercise files so that you can do the same thing. So I'm just going to paste this query for setting up the table in this window here. And then click the little lightning bolt icon. And we should see that it completed successfully down at the bottom. And once we've created the table, let's populate it with a few new records. And for that, I'm going to copy and paste some SQL as well, which will also be in the exercise files for you. And then we're going to click the lightning bolt icon again. And actually, in order for this query to work inside MySQL Workbench, we have to go over to Schemas and double-click on Buy and Sell, and then click the lightning bolt icon. Not very self-explanatory, but that's what we have to do. And once we've done that, we need to add another user to this database, just like we did before. And we're going to click on Users and Privileges, and then we're going to go to Add Account. And for the login name here, we're going to use Happi Server, just like before. For the password, I'm just going to do something simple. and then confirm the password, and then we're going to click on Apply. Make sure that this Happi server user is selected, and we're going to go to Schema Privileges, and we're going to click on Add Entry, and we're going to do Selected Schema, Buy and Sell, just like we did before. And then for object rights, we're going to give it Select, Insert, Update, and Delete privileges, and click Apply. And that should be all of the setup that we need to do for our database for the time being. So now what we're going to do is we're going to head over to our backend repository and open up our database.js file. And we're going to need to make some changes to the object that we're passing to MySQL.createConnection here. First off, for the host property, we're going to have to change this to the public IP address of our MySQL instance on the cloud. So let's copy that again and paste that in here. And then if you gave a different username or password to the user we just created, you'll need to change those here. I gave mine the same one. And then for the database, this is going to be the name of the schema that we created earlier. So that's just going to be buy and sell. And now we're going to want to save this file. And it's also not a bad idea to restart our server. And if we take a look at our app now, we should see that this is now connected to the MySQL database that we created on Google Cloud. And in My Listings, we still have nothing there. So we should be able to create a new listing now. I'll just use the same ones that I've already created. And that works. And deleting it works as well. So everything is still working like we want it to, except now the MySQL database is on Google Cloud instead of running locally. Okay, so previously we saw how to point our Happi server at the cloud-based MySQL instance that we created. However, in real life, when we have several different databases available for our backend to connect to, we'll want to have a way to break those details out into separate files that get loaded into our server automatically. And the way that we generally do this in full-stack apps is by using something called environment files. Basically, environment variables just contain a number of different variables and values that should be different based on where our code is being executed from. So for example, we'll want the values that we pass to this create connection to be different depending on whether we're running our server locally or whether it's running on the cloud. So here's how we use environment files on a Node server. We're going to start off by installing a package called .env that will basically take an environment file and assign whatever values it contains to our app's environment. And we'll see exactly how this works shortly. So to install this .env package, let's run npm install .env and hit enter. And then we're going to create an environment file, which is just called .env by default, hence the name of that package we just installed. So in the root directory of our project, let's create a new file called .env. And then inside here, we're going to add the old values that we just replaced to it. So we're going to say db user equals Happi server, db pass equals abc123 exclamation point, db name equals buy and sell. And then for db host, we're going to put localhost because this environment file is what's going to be used when we run our code locally. We'll want it to be localhost here. And once we've done that, we're going to go into our server file. And up at the very top, we're going to import our .env package. So import .env from .env. And then we're going to say .env.config. And that should take care of taking all these variables that we've defined inside this file and setting those environment variables on our server when it runs. So what we're going to do now is instead of having all these strings hard-coded here, we're going to use environment variables that we just defined. So for host, we're going to say process.env, which is how we access environment variables in Node.js. And then we're going to say db host. And then for user, we're going to say process.env.db user. And then for password, process.env.db pass. And then for database, process.env.db name. And then what we need to do is we need to move this code where we define our connection into this connect function. So we're going to just copy connection equals mysql.createConnection. And we're going to need to change this from a comma to a semicolon. And then up here, we're going to need to say let connection so that the rest of our app has access to that. And the reason that we're doing this here is to make sure that these environment variables are already set before this code actually gets executed. So now let's run our server again with npm run dev. And now we should be able to take a look at our app again and see that it's connecting to our local database, which is what we defined inside our environment file. Okay, so now that we've got some environment variable stuff set up, the next thing we're going to do is we're going to move our entire Happi server to Google Cloud. And to make this happen, what we need to do is create a new file in the root of our backends directory. So we're going to say new file, and this file is going to be called app.yaml. And then inside this file, we're just going to add a few configuration options. So we're going to say runtime, Node.js, environment flex, and beta settings. We need to say cloud, SQL instances. And then what we need to do is we need to go back to the cloud console, and we need to find this connection name here and copy that. And then we need to paste that here. And once we've done that, the last thing we need to add to this file is some environment variables that will be loaded into our server when it's running on Google Cloud. So this is in contrast to the .env file that we just created in the previous video. And that's going to look something like this. We just have to say env variables. And then we're going to define the same kind of variables that we did in our environment file. We're going to have db user, and that's going to be Happi server. db pass is going to be abc123. db name is going to be buy and sell. And then, since these variables are what's going to be loaded when it's running on Google Cloud, instead of having db host, which actually won't work in our particular situation, we're going to add something called db socket, and you'll see how this is used in a little while. And the value for this is going to be /cloud SQL /, and then this connection name that we just copied and pasted from the cloud console. So we're going to paste that there. And then we're going to save this file. And then we need to go into our database.js file. And because we're using this db socket environment variable when it's running on Google Cloud instead of db host, what we need to do is add another thing to our create connection object called socket path. And the value for that is going to be process.env.dbsocket. And next, there are just two changes that we need to make to our server.js file. So let's open that up. What we need to do is we need to change the port number and the host name that our server is running on. See, Google Cloud expects our server to be running on port 8080, and in order for all of this to work, we'll also have to change the host name here from localhost to 0.0.0.0. And that's just the way we have to do it on Google Cloud. So now that we've done those things, there's one last thing we're going to have to do on our backend. You see, we've been using the Babel node package during development to allow us to write and run modern JavaScript code. But to run our code in production, we'll need to use Babel to actually build all of our code, and then we're going to need to run the built version of our code. So let's open up our server's package.json file here. And down here in the scripts section, we're going to add a build script to it. And for that script, we're just going to say Babel, and then /source --out directory /build. What we're saying is we want it to build all of our files and put it into the build directory. And we need to add a comma to the line above that. And the next thing we're going to need to do is we're going to add a start script to our project. This is what Google Cloud will be looking for and what it'll call once we've deployed our server to make it actually run. So we're going to say start, and for that we're just going to say node, and then run the built version of our code inside build/server.js. And now that we've done all of that, let's kill our server here, And now that we have those scripts defined, we're going to need to actually build our application. So first, we're going to need to install something called Babel CLI so that our Babel command will actually work. So say npm install at Babel CLI, save dev. And once we've done that, we should be able to build our code by running npm run build. And what that'll do is create this build directory for us that contains a transpiled version of our code that can be executed in a Node environment. And one last thing that we're going to have to add into our package JSON here is a property called engine that will tell Google Cloud what version of Node to use while running our server. So that's going to look like this. We're just going to say Node, and then for the version, we're going to say greater than or equal to 12.0.0. And the reason we need this is because Happi doesn't work with versions of Node that are less than 12. So we just need to make sure that our server is running on a Node version that's higher than 12. And make sure you add the comma there. And the command to deploy our server is going to be gcloud app deploy, and hit enter. And since we've had this terminal open and haven't refreshed it since we installed gcloud, what we're going to do is just open up a new terminal and run it from there, where gcloud should be available from. So we're going to say gcloud app deploy and hit enter. And it's going to ask us what region we want our app to be running in. We're going to want to choose whichever one is closest to us here. So I'm going to do US Central. And for that, I'm going to enter in 14. And then it's going to ask us if we want to continue, and we're going to say yes. And generally, this deployment does take a pretty long time, so don't worry if it runs for a while. And once this whole deployment process completes, we should be able to connect to it from our front end. So let's head over to our front end, and inside our proxy config file, we originally had our front end pointing at our server running locally, but what we're going to do now is change that to the URL that our backend is currently being served on the Google Cloud. So that URL is right here where it says deployed service to, and then we're going to copy this and paste it inside this target string here. And we might have to restart our front end as well. So we're going to say npm run start. And now we should be able to run our front end locally, all while accessing our server running on Google Cloud, which is pretty cool. So now we've come to the last piece of our full stack hosting puzzle, and that's building and serving our front end from Google Cloud. Now this process has a few steps. The first step here is going to be to build our front end application, and to do that we need to run the command ng build and hit enter. And what this command does is it compiles our entire Angular application into basic HTML, CSS, and JavaScript files that can simply be loaded and executed by the end user's browser. And once this script finishes running, all of this compiled code is put into this dist directory here. So here's how this is going to work. What we're going to do is have our Happi server serve all the files in this dist directory, along with all the API routes that we've created throughout this course. So to do that, the first thing we're going to do is we're going to copy this dist directory, and we're going to paste it into our backend's root directory. So we're going to copy, and then we're going to paste it right here. And then what we're going to do is we need to install another Happi module package into our backend project. So we're going to say npm install, and the package we're going to be installing is called @happy/inert. And this package makes it easier for Happi to serve static files. So once we've done that, we're going to open up our server.js file, and we're going to import the package we just installed. So we're going to say import inert from @happy/inert. And then we need to register this package with our server by saying await server.register inert. And the next thing we have to do here is define some routes for serving the front-end files we copied and pasted. So here's what that's going to look like. We're going to start off by defining a route for serving static files from the dist folder. So inside our routes folder, we're going to create a new file called files.js. And inside of there, we're going to say export const static files route equals, and the method for this is going to be get. And then for the path here, we're going to say slash curly braces params star, which basically will match any route. And then we're going to have handler directory and path dist slash, and then we need to look inside of our dist folder to see what the name actually is. In our case, it's just buy and sell. So we're going to say dist slash buy and sell. And the next thing we have to do is define routes on our server for each route on our front end. Basically, for all of those routes, like slash listings, slash edit listing, and so on, we'll simply want to return the index.html file found inside this dist folder. And once we do that, Angular will take care of the rest. So the way that we're going to do this is inside the same file, we're going to define an array called Angular route paths. And this will contain all the paths that we want to open up to our front end. So we're going to say slash, we're going to have the slash listings route, we're going to have the slash contact slash ID route, we're going to have the edit listing route, we're going to have the listings slash ID route, we're going to have the slash my listings route, and last but not least, we're going to have the new listing route. And now that we have this, what we're going to do is we're going to map each of these paths to a route that will return the index.html file of our front end. So here's what that'll look like. We're going to say export const files routes equals Angular route paths.map. And for each path, what we're going to do is return a route with the method get and the given path that we're mapping. And then for the route handler, we're going to say request and h. And we're going to say return h.file. And then dist slash buy and sell slash index.html. And then we're going to need to export both the files routes and the static files route from our routes index.js file. So we're going to say import static files route and files routes from files. And then down here at the bottom of our array, we're going to say static files route, and then use the spread operator to put all of our files routes into this array. And now that we've made changes to our app, we're going to have to actually build it again by running npm run build. And once we've done that, we should be able to run gcloud app deploy and hit enter. And we're going to say yes. And while that's deploying, there's one more thing we need to do. We need to tell Firebase Auth to trust the URL that our app will be running on. And the way that we do this is by going to the Firebase console, and we're going to go over here to authentication and click on that. And then we're going to click on sign-in method. And then we're going to scroll down to this section that says authorized domains. And what we're going to need to do is we're going to need to add a domain here. And the domain that we're going to add is the one that we put inside our proxy config on our front end. So we're going to copy that and paste it into here and click add. And that should be all we need to do for Firebase Auth to work with our deployed application. So now all we have to do is wait for the deploy to finish. And once our application has been successfully deployed, what we can do is we can either copy and paste this link into our browser, or we can just type gcloud app browse. And that'll bring up our entire application in a browser on a URL that anyone can visit. So let's just walk through to make sure everything works. We're going to sign in with Google. Editors, please blur these out. And we can go through and take a look at some of the listings. We can then go to My Listings and create a new listing. And there it is. And we can also edit it and save our changes. And we can also delete it. And that's it. We've built and deployed a full stack Angular application. So we've covered quite a few topics in this course. We started off by creating a front-end application using Angular and a back-end using Node.js, Happi, and MySQL. We then saw how to bring the front-end and back-end together using Angular's HTTP client to make network requests, and then we saw how to add user authentication to our application using Firebase Auth. And this allowed us to protect our endpoints and keep better track of our users and the listings they created. And finally, we saw how to move the entire application that we created to the cloud using the Google Cloud Platform so that users would be able to actually access our application. Now, I want to reiterate that all of this work that we've completed is a pretty impressive undertaking, and it's something that most web developers don't know how to do. So you should be very proud of yourself if you followed along with all the steps and understand all the concepts we've covered here, since that'll put you very far ahead of the vast majority of web developers today. So now that you've got all this full stack development knowledge, you might be wondering where to go next. Well, there are several things that I'd recommend. First and foremost, I'd recommend that you use everything you've learned here to build your own site. Not only will this allow you to apply your knowledge to solve real-world problems, but whatever you end up building will be a great portfolio piece for potential employers if you're looking for a full-stack development job. Never underestimate the power of being able to walk into a job interview with a real-world full-stack site that you've built that your interviewers can visit.